Hello, friend, and welcome to the Sleepy Meteorologist. Tonight, we're gently drifting into the quiet mystery of fog, how it forms, why it vanishes, and why it sometimes seems to appear out of nowhere, like a secret the earth exhales at dawn. Maybe your day has been long, or maybe you're simply ready to let the soft rhythm of weather stories carry you somewhere slower, somewhere softer. How's the sky looking where you are? Is it clear and starlit, or wrapped in a thin silver haze? Fog is one of the gentlest moods of the atmosphere. It doesn't rush, it doesn't roar, it simply gathers, bead by bead, until the world feels smaller, quieter, closer. If you enjoy these calming meteorology journeys, feel free to like or subscribe, but only if it feels right. There's never any hurry here. For now, you can snuggle in. Let your breath deepen, slow and steady, like evening air settling into a valley. There's nothing you need to solve, nothing you need to understand all at once. Just listen and let the weather move softly around you. Let's begin. We begin with the softest cloak the sky can wear, fog. It is not simply a cloud that has wandered too low, though that is, in essence, what it is. It is a cloud that has chosen the earth instead of the open sky. A quiet atmospheric veil formed from countless microscopic droplets suspended gently in the air around us. Each droplet is so small that it floats with ease, held aloft by subtle movements we never quite feel. Fog does not fall like rain. It does not streak or splash. It lingers, it hovers, it rests, and in that resting, it transforms the familiar. A field you know by heart, softened. A street you've walked 100 times, hushed. A tree line in the distance, erased, then hinted at again. Fog touches landscapes gently, hiding what was visible only moments ago. It does not remove the world, it simply redraws its edges. Often, it arrives silently, without announcement. You might open a door to clarity 1 hour, and to silver obscurity the next. No thunder, no dramatic shift in wind, just a gradual thickening, as though the air itself has decided to exhale. To understand this soft disguise, we drift into 3 quiet companions: temperature, moisture, and stillness. Air always carries water vapor, an invisible presence woven into every breath. On warm days, air can hold more vapor. On cooler evenings, its capacity shrinks. When the air cools enough, it can no longer hold all that invisible moisture. And so, the excess gathers. Not in urgency, not in chaos, but in tiny beads of suspended water, forming droplet after droplet, until the air turns luminous. Stillness plays its part too. Fog favors calm. When winds are light, the droplets are allowed to gather and remain. Strong winds would scatter them, blend them, move them along. But in quiet air, especially overnight, fog finds stability. It settles into valleys. It curls along lake shores. It drapes low hills like a shawl. There are many kinds of fog, though we won't rush to name them all. Some form as the ground cools after sunset, chilling the air just above it. Some form when warm, moist air glides over cooler land or water. Some appear when gentle rain moistens the air to its limit. But all share the same essence: air reaching a delicate balance and tipping softly into visibility. What makes fog feel mysterious is not its science, which is beautifully simple, but its effect. Sound feels closer in fog. Light becomes diffused, scattered by droplets, glowing rather than shining. Even distance feels different. The world seems smaller, quieter, held in a suspended pause. And yet, fog is temporary. As the sun rises and warms the surface, the air regains its capacity to hold moisture invisibly. The droplets evaporate, the veil thins, shapes return, edges sharpen. Nothing dramatic, just a quiet lifting. Fog is not a disappearance. It is a phase, a moment when the atmosphere reveals the moisture it usually keeps hidden. A mood, a mystery, a whisper from the sky. And as we drift onward, we'll move deeper into the invisible threshold where fog is born, a gentle boundary known as the dew point, where air and water meet in the softest possible way. At the heart of fog is something you cannot see, and yet it shapes what you do see. The dew point. It sounds technical, perhaps, but it is simply a temperature, a quiet threshold, where air becomes saturated and water vapor begins to condense into droplets. To understand it, imagine the air as a spacious room. Inside this room floats invisible water vapor, moving freely between oxygen and nitrogen molecules. Warm air is like a larger room. It can hold more vapor comfortably. Cool air is smaller. Its capacity is gentler, more limited. The dew point is the moment the room becomes full. When air cools to meet this temperature, it can no longer keep all its vapor invisible. The excess moisture gathers together, molecule by molecule, forming tiny droplets, not yet rain, not falling, just suspended, creating mist, dew, or fog. It is a dance between temperature and humidity. Humidity tells us how much moisture is present, compared to how much the air could hold at that temperature. When we say the humidity is 100%, we mean the air is fully saturated. The dew point is the temperature at which that saturation occurs. If the air is already very moist, the dew point will be close to the current temperature. Only a slight cooling is needed for droplets to form. On such nights, fog can appear easily, almost effortlessly. If the air is dry, the dew point sits much lower. The temperature must fall significantly before condensation begins. So, imagine evening arriving. The sun lowers. The ground releases the warmth it gathered during the day. Air near the surface cools gradually, quietly. As it cools, it inches closer to the dew point, closer to that invisible line. And then, softly, it meets it. Tiny droplets begin to form around microscopic particles in the air, specks of dust, salt, or pollen, so small we never notice them. These particles act as gentle anchors, allowing water molecules to gather. Droplet by droplet, the haze thickens. This is not an abrupt transformation. It is gradual, like breath on cool glass. The dew point itself does not create fog. It simply marks the condition where fog becomes possible. It is a balance beam in the sky, tipping ever so slightly toward visibility. And this balance is delicate. A single degree of warming can dissolve the mist. A faint breeze can mix drier air downward, lifting the saturation. The dance continues, always adjusting. You may have noticed dew forming on grass in the early morning. That is the dew point at work as well. When surfaces cool below the dew point temperature, vapor condenses directly upon them. Fog is simply dew suspended in air. It is the same process, just floating. In this way, the dew point is less a number and more a meeting place, a quiet convergence of warmth and moisture, a threshold where the invisible becomes visible. And as we move gently forward, we'll explore how cooling happens in different ways. Over land, over water, beneath clear skies, shaping fog into many forms, each with its own soft personality. Fog is born from quiet. Unlike storms that announce themselves with towering clouds and distant rumbles, fog prefers the gentlest conditions. It does not gather in restless air. it does not thrive in rushing wind. It waits for stillness, for that peaceful pause in the atmosphere when movement softens and the world begins to settle. Imagine evening unfolding slowly. The sun lowers and slips beyond the horizon. The warmth of the day begins to loosen its grip on the land. Shadows stretch, colours fade into muted blues and silvers, and gradually, almost imperceptibly, the breeze begins to quiet. Wind is simply air in motion, air moving from one place to another in response to pressure differences. During the day, sunlight warms the surface unevenly. Some areas heat more quickly than others, and this imbalance stirs the air into motion. But at night, when sunlight withdraws, those differences soften. The atmosphere begins to equalize. The wind relaxes. And in that relaxation, something special becomes possible. When air is moving quickly, moisture is constantly mixed and redistributed. Drier air may blend with moist air. Slight temperature differences are stirred together. The atmosphere remains active, dynamic. But when winds grow calm, the lower layers of air are allowed to linger close to the surface. Moisture stays near the ground. Cooling remains localized. The air is given time, and fog, above all, requires time. As the ground cools after sunset, it chills the thin layer of air resting directly upon it. If winds are gentle, this cooling remains undisturbed. The air temperature slowly approaches the dew point, that quiet threshold we explored before. Nothing dramatic happens. There is no signal, only a subtle thickening. Stillness allows tiny droplets to form and remain suspended. Without gusts to scatter them, they gather. Molecule by molecule, they coalesce around microscopic particles, hovering in place. You might notice it first as a softening of distant lights, a halo around a street lamp, a slight blurring of the horizon. This is the atmosphere forgetting to move. Valleys often feel this stillness most deeply. Cool air, being slightly denser, gently flows downhill after sunset, pooling in low-lying areas like water filling a basin. With little wind to disturb it, that cool, moist air settles and saturates. Fields grow quiet. Lakes lie smooth as glass. Even sound seems cushioned. Fog takes its first breath here, not in motion, but in pause. And there is something profoundly calming about this process. The same physics that governs great weather systems also governs this quiet formation. Temperature, moisture, air pressure, all following their natural rhythms. But in stillness, those rhythms feel slower. Fog reminds us that the atmosphere does not always need energy to create beauty. Sometimes it needs only calm, a reduction, a softening, and when morning eventually arrives, the return of sunlight will stir the air once more. Warmth will rise, gentle currents will reawaken, the droplets will evaporate, returning invisibly to vapor. But for a while, in that peaceful moment when the breeze stops and the sky forgets to move, fogs lingers, a quiet presence, a soft awakening born not from force, from angst, but from rest. As night falls, the earth begins to glow, not with visible light, but with energy. All day long, the surface absorbs sunlight. Soil, grass, pavement, rooftops, each gathers warmth beneath the bright sky. But when the sun sets, that incoming energy ceases. The ground, no longer replenished, begins to release the heat it stored. This release is gentle, continuous, invisible. It is called radiation, the emission of energy as infrared waves drifting upward into the darkening sky. On clear nights especially, this heat escapes freely. Without thick clouds to reflect it back downward, the warmth radiates into space. The surface cools steadily, hour by hour. And as the ground cools, so does the air resting directly above it. Picture yourself lying quietly in a field beneath a starlit sky. The grass beneath you slowly loses warmth. The air just inches above the blades begins to chill. There is no wind to mix it away, no clouds to trap the warmth, just quiet cooling. This is the birthplace of radiation fog. As the surface temperature drops, the air touching it also cools. If that air contains enough moisture, and often it does, especially after a humid day, its temperature will eventually meet the dew point. At that moment, saturation occurs. Tiny droplets begin to form within the shallow layer of cooled air. They do not descend from above. They rise from below, emerging right at the surface. Radiation fog is grounded. It forms from the earth upward. At first, it may appear as a thin veil hugging the grass. Then, gradually, it deepens. Inches become feet. The mist thickens, spreading across fields and along quiet roads. Because the cooling happens most efficiently under clear skies and light winds, radiation fog is often a companion to tranquil nights. The same calm that allowed heat to radiate freely also allows droplets to remain suspended. In valleys, the effect can be even more pronounced. Cool air drains downhill, pooling in low areas. The temperature there may fall more quickly than on surrounding hills. Fog gathers first in these basins, creating what looks like a silver lake under the stars. From a distance, hills may rise above the mist like islands. And overhead, the stars blink softly, undisturbed by the quiet transformation below. Radiation fog is temporary. It depends on continued cooling. Once the sun rises, its light warms the surface again. The ground absorbs energy. The air temperature increases. As the air warms above the dew point, the droplets evaporate. The veil lifts. What was hidden returns. But for a few gentle hours before dawn, the earth performs this quiet exchange, releasing heat, cooling its surface, allowing moisture to reveal itself as mist. A grounded mystery, a fog born not from clouds above, but from heat's slow, graceful escape into the night. Some fog does not simply appear. It gathers, it collects, it flows. In certain landscapes, where mountains cradle lowlands and hills bend gently toward basins, fog behaves almost like water. It drifts downslope, settles into hollows, and pools in valleys as though poured there by invisible hands. Tonight, we wander into those quiet places. As evening falls and the sun withdraws its warmth, the higher elevations begin to cool first. Mountain slopes lose heat steadily, radiating it into the open sky. The air touching those slopes cools as well, and cool air, being slightly denser than warm air, moves differently. It slides, not quickly, not dramatically, but gradually. Gravity encourages it downward. This gentle downhill movement is known as cold air drainage, and it is one of the soft architects of valley fog. Imagine standing on a mountainside at dusk. The air feels calm. The trees are still. Slowly, imperceptibly, a thin layer of cooler air begins to glide along the slope, following the natural contours of the land. It collects in the valley below, just as water would. And in that sheltered hollow, something special happens. As more cool air settles, the valley floor becomes a basin of lower temperature. If moisture is present, perhaps from a nearby river, damp soil, or the lingering humidity of the day, the cooling air approaches its dew point. Saturation arrives quietly. Tiny droplets form. At first, it may look like a faint mist hovering above fields or winding along a stream. But as cooling continues and more air drains downward, the fog deepens. it spreads laterally, filling the valley from side to side. From above, valley fog can resemble a silver river flowing between dark ridges. Peaks rise like islands from a luminous sea. The effect is cinematic, serene, almost otherworldly. And yet, the science is simple. Cold air sinks, moisture condenses, stillness preserves the formation. Valley fog often lingers longer than other types of fog because the surrounding terrain shelters it from wind. The mountains act like gentle guardians, protecting the cool, saturated air from mixing with drier air above. In the early morning hours, the valley may be entirely filled, while higher elevations remain clear and starlit. Sound behaves differently here. It carries softly through the mist. Lights glow diffusely. Distance becomes a suggestion rather than a certainty. There is no rush. In valley fog, its movement is slow, a subtle reshaping rather than a dramatic shift. Even as the night deepens, the fog simply rests, layered and quiet. Eventually, sunrise begins its patient work. Sunlight touches the upper slopes first, warming them gently. Gradually, warmth trickles downward into the basin. As temperatures rise above the dew point, droplets evaporate. The silver river thins, contours reappear, fields and roads emerge as if waking from a dream. But for a while, nestled between mountain arms, valley fog remains, a river of cloud, a pooled whisper of cooled air, a reminder that the landscape itself shapes the sky. Some fog stays in place, but some fog travels. Advection fog forms not from stillness alone, but from movement, a gentle glide of warm, moist air across a colder surface. And in that meeting of contrasts, a quiet transformation occurs. Let us drift toward the coast. Over the ocean, especially in milder seasons, air can become warm and richly infused with moisture. Water evaporates continuously from the sea's surface, adding invisible vapor to the atmosphere above it. When winds guide this moist air inland, it carries that warmth with it. But the land, or the water beneath, may be cooler. If the warm air passes over a colder surface, it begins to cool from below, not abruptly, not harshly, but steadily, as though the ground is gently drawing heat away. As the air temperature lowers toward its dew point, condensation begins, droplets form, and fog emerges. This is advection fog, born from motion and contrast. Unlike radiation fog, which forms under clear, calm nights, advection fog often arrives with a soft breeze. It glides inland from oceans, wrapping harbours, meadows, and cities in a woolly hush. You might see it first offshore, a pale bank hovering above the water. Then slowly, carried by steady winds, it rolls toward land. It spills through coastal inlets. It weaves between buildings. It stretches across chilly fields. Its movement is smooth, continuous, like breath moving in and out. Because advection fog depends on horizontal movement of air, it can cover vast areas. Entire coastlines may rest beneath its quiet canopy. Lighthouses glow dimly through it. Boats drift within it. Hills disappear and reappear as the fog thickens and thins. The key is temperature difference. Warm, moist air meets a colder surface, perhaps a cool ocean current, chilled sand, or soil that has not yet warmed. The lower layer of air cools first. If cooling reaches the dew point, droplets gather within that layer. And because winds continue to supply more warm, moist air, the fog can persist as long as the temperature contrast remains. Advection fog is common along certain coasts, where cold ocean currents flow beneath warmer air masses. It can also form over snow-covered ground when milder air moves in above it. Despite its travelling nature, there is nothing hurried about it. It drapes rather than strikes. It envelops rather than overtakes. Cities beneath advection fog feel quieter. Skylines soften. Bridges stretch into mist. Even familiar streets take on a cinematic stillness. Eventually, the contrast fades. Perhaps the ground warms under sunlight, or winds shift, bringing air of a different character. As temperatures rise above the dew point, droplets evaporate. The fog lifts, but for a time, warm air meeting cold ground creates a wandering veil, a traveller of the atmosphere, a fog that moves, a fog that whispers, a gentle reminder that when air journeys across changing landscapes, it sometimes reveals its moisture in the softest way imaginable. Sea fog is born from the ocean's breath, out across wide waters where horizons stretch uninterrupted and tides move in patient rhythm. The air and sea are always in quiet conversation. The ocean releases moisture continuously, sending invisible vapor upward into the marine air. It is a gentle offering, a steady exhale, rising from the surface of waves. Sometimes, that moist maritime air drifts across colder water. In certain regions of the world, ocean currents carry chilled water from distant latitudes. These currents move beneath warmer air that has travelled from sunnier places. When that warm, moisture-laden air glides over the cooler sea surface, it begins to cool from below. Not suddenly, not dramatically, but steadily, like a warm hand resting against cool glass. As the lower layer of air cools toward its dew point, condensation begins. Tiny droplets gather, suspended in the marine layer just above the surface. Gradually, a pale veil forms, thin at first, then thickening into a soft blanket. This is sea fog. From a distance, it may appear as a low bank hovering offshore, like a quiet shoreline made of cloud. Ships move toward it and slowly dissolve into silver. Lighthouses blink steadily, their beams diffused into halos. The boundary between water and sky becomes uncertain. Sea fog is often guided by gentle winds. Carried inland, it rolls across beaches and harbours, spilling between piers and drifting along coastal roads. It does not crash ashore like a wave. It arrives softly, layer by layer. As it moves over land, it can cool the air further, maintaining its presence. Cliffs fade into suggestion. Waves soften at their crests. Even sound seems to travel differently, muffled, intimate, close. The science beneath this softness is beautifully simple. Warm, moist air meeting a colder surface, cooling to saturation, droplets forming in suspension. Yet, the experience feels almost timeless. Coastal communities often wake to sea fog in the early morning hours. The ocean may remain hidden, while gull calls echo through mist. The sun, rising behind the veil, turns the fog luminous, glowing rather than shining. Eventually, sunlight warms the surface layers of air. Mixing begins. The temperature rises above the dew point, and the droplets evaporate. The blanket thins, edges return, blue reappears. But for a while, sea fog rests like a memory half remembered. It reminds us that the ocean is never still in its influence. Even when waves are calm, even when tides are gentle, the sea shapes the air above it. It cools it, moistens it, transforms it. And when conditions align, warm maritime air, cool water, steady movement, the ocean exhales visibly, a coastal veil, a drifting hush, a softening of waves, cliffs, and memory itself. Some fog settles low, some fog travels across water, and some fog prefers to climb. Upslope fog forms when moist air is gently guided upward along rising terrain. Hillsides, ridges, and mountain slopes become pathways for air that is already rich with invisible vapor. As air ascends, something subtle happens. Temperature decreases with height in the lower atmosphere, not abruptly, but gradually. For every 1,000 feet of ascent, the air cools a few degrees. This cooling occurs because rising air expands into lower pressure, and expansion leads to gentle cooling. So imagine moist air approaching a mountain. There is no rush, no turbulence, just steady movement driven by prevailing winds. As the air encounters the slope, it cannot pass through solid earth. Instead, it follows the contour upward, and as it rises, it cools. If the air contains enough moisture, its temperature will eventually meet the dew point during this ascent. At that quiet threshold, condensation begins. Tiny droplets form within the rising layer, suspended in place. Fog emerges along the slope itself. Unlike valley fog, which pools below, upslope fog clings to the land. It wraps around hillsides and drapes across summits. It can appear as though clouds have lowered themselves to rest against the earth, or perhaps as though the mountains themselves are breathing mist. From within, the experience feels immersive. Trees fade into soft outlines. Rocks bead with moisture. The air feels cool and gently saturated. The formation is steady and sustained as long as the upward flow continues. Winds need not be strong, only consistent enough to guide moist air upslope. Terrain and airflow blend into a seamless partnership. Mountains shape the path of air. Air responds by revealing its moisture. Upslope fog often persists on windward sides of hills, while the opposite slopes remain clearer. The land itself becomes a sculptor of visibility. There is something poetic about fog that climbs. It moves upward like a thought rising slowly. It curls along ridgelines and gathers in high meadows. It makes peaks appear taller by hiding their bases, or smaller by concealing their tops. Eventually, conditions shift. Perhaps winds weaken, perhaps drier air replaces the moist flow. As the ascent slows or moisture diminishes, the fog begins to thin. Droplets evaporate, contours sharpen, the mountains re-emerge. But for a time, clouds prefer to walk. They trace the shape of the land. They linger on slopes. They remind us that elevation changes not only the landscape, but the air itself. In upslope fog, we see the atmosphere responding to terrain, cooling as it climbs, condensing as it rises. A gentle ascent, a quiet wrapping of hill and summit, a fog that moves upward, slowly, as though the sky has chosen to explore the mountains from the ground up. Imagine a lake before sunrise. The surface is still as glass, reflecting the faintest hint of early light. The shoreline rests in silence. No ripples, no wind, just water holding the memory of yesterday's warmth. Now imagine the air above it, crisp and cool, perhaps after a clear night when temperatures have quietly fallen. The land has cooled quickly in the darkness, and the air resting above it has followed. It feels fresh, almost weightless, like a slow inhale waiting to be released. And then something subtle begins. The lake, having stored heat longer than the surrounding land, remains slightly warmer than the air above. Water, cools more slowly than soil or stone. So, while the morning air has turned cold, the lake still carries a gentle warmth within its surface layers. From that warmth, vapor rises. Evaporation is always happening over water, invisible molecules escaping the surface and drifting into the air. But when cold air settles over warmer water, the contrast becomes visible. The rising vapor meets the chilled air just above the surface. And there, in that delicate meeting, the air cools to its dew point almost instantly. tiny droplets condense from the vapor, forming wisps of mist that hover and curl above the lake. This is evaporation fog, sometimes called steam fog. It looks like breath. Soft tendrils rise, twist, and vanish, then rise again. Unlike other fogs that form from cooling air alone, evaporation fog depends on the addition of moisture from below. The lake offers warmth and vapor. The cold air provides the cooling needed for condensation. Together, they create a fleeting display. From the shoreline, it may appear as though the lake itself is exhaling. The mist gathers in thin columns and drifts lightly with the faintest movement of air. It is rarely dense. More often, it is delicate and shifting, a series of gentle plumes rising and dissolving in quiet rhythm. You might notice how it changes moment by moment. A patch forms, lingers briefly, then fades as the air mixes. Another appears nearby. The process is continuous, yet never hurried. As the sun climbs higher, warming the air, the contrast lessens. The temperature difference between water and air narrows. Evaporation continues, but condensation becomes less likely. The visible mist thins. And yet, if a breeze of colder air passes again, perhaps from shaded forest or distant snow, the mist can return just as softly. A fog that rises, disappears, then returns. Evaporation fog reminds us that visibility in the atmosphere often depends on contrast. Warm meeting, cold, moisture meeting, chill. It is not dramatic. It is not forceful. It is a quiet exchange between water and air. And sitting beside that sleepy lake, watching the surface breathe, we are witnessing the simplest of atmospheric truths. When warmth offers vapor to cold air, the invisible becomes visible for just a moment. A rising whisper, a silver breath, the gentle birth of mist at dawn. There are nights when the air grows colder still, not just cool, but sub-freezing, dipping below the quiet threshold of 0 degrees Celsius or 32 degrees Fahrenheit. In such air, fog can take on a more delicate character. Freezing fog begins much like any other fog. Moist air cools to its dew point. Tiny droplets condense and remain suspended, forming a soft mist. But in this case, the temperature of the air and the surfaces it touches is below freezing. The droplets within the fog are often supercooled, meaning they remain liquid even though their temperature is below the freezing point. Water can do this under certain conditions, especially in very small droplets, where there are few impurities to trigger crystallization. They float quietly in the air, liquid yet colder than ice. When these supercooled droplets encounter a surface, a tree branch, a railing, a fence wire, they freeze on contact. Instantly, gently, they transform into tiny ice crystals. This creates rime. Rime ice forms as layer upon layer of frozen droplets accumulate, building a feathery, opaque coating. It often grows on the windward side of objects, where fog droplets drift most readily. Trees sparkle, rails glisten, even blades of grass take on crystalline edges. The transformation is subtle but enchanting. Unlike clear glaze ice from freezing rain, rime appears frosted, textured, almost soft in its structure. It scatters light in countless directions, giving surfaces a quiet shimmer. In stillness, freezing fog can turn an ordinary landscape into something luminous. Breath becomes visible too. Each exhale releases warm vapor into cold air, condensing instantly into tiny clouds that linger briefly before fading. There is no urgency in freezing fog. It forms in calm, stable conditions, often during long winter nights when winds are light and temperatures steady. The same peaceful stillness that allows regular fog to gather also supports this crystalline version. Though it can make surfaces slick, we will not dwell on caution tonight. Instead, we focus on the transformation itself, the way mist becomes sculpture. Streetlights glow through the fog, their halos refracted by ice-laced air. Branches grow thicker with frost, each twig outlined in white. Fences appear delicately carved. And then, when temperatures rise above freezing, or when sunlight warms the surfaces, the ice softens. Droplets melt. Crystals release their hold. The rime disappears as quietly as it formed. Freezing fog is a sculptor that works in whispers. It does not chisel. It does not carve with force. It simply offers droplet after droplet, freezing them in place until the landscape wears a coat of quiet lace. A crystalline dream, a moment when mist becomes frost. And in that still, shimmering air, the boundary between vapor and ice feels impossibly thin, a reminder that even the gentlest fog can reshape the world in delicate, sparkling ways. Cities have their own fog language. While fog in open countryside drifts freely across fields and valleys, fog in a city must learn to weave. It slips between towers, curls around street corners, and lingers in alleyways like a quiet guest who knows the shape of every building. Tonight, we wander through an urban landscape softened by mist. In the daytime, cities absorb and store heat. Concrete sidewalks, asphalt roads, brick walls, glass towers, all of them soak up sunlight and warmth. Even after sunset, they continue releasing that stored heat slowly into the air. This is one reason cities often remain warmer than nearby rural areas at night, a phenomenon known as the urban heat island effect. And this warmth changes how fog behaves. Sometimes, the city's warmth can prevent fog from forming because air that stays warmer is less likely to cool to the dew point. But other times, that same warmth creates gentle pockets of rising air, mixing moisture and temperature in subtle ways. Fog becomes a traveler here, adjusting itself street by street. The atmosphere above a city is also different in composition. Tiny particles from car exhaust, industrial activity, and even natural dust become suspended in the air. These particles, though invisible to us, provide perfect surfaces for water vapor to condense upon. In a way, the city gives fog more places to begin. Condensation nuclei, those microscopic anchors, allow droplets to form more easily. And so, in urban air, fog may develop with a slightly thicker, milkier texture, especially under calm conditions. Imagine a late evening downtown. The streets are quiet now. Traffic has softened into occasional distant murmurs. Windows glow warmly in high-rise buildings, like lanterns suspended in the dark. Streetlights line the roads, their beams shining into the mist. And when fog arrives, it changes everything. Light scatters through the droplets, creating halos around lamps. Headlights stretch into pale beams. Neon signs blur into watercolor smudges. The city feels cinematic, like a scene gently paused. Fog does not erase the skyline completely. Instead, it layers it. The closest buildings remain solid, while those farther away dissolve into soft outlines, their edges fading as though drawn in charcoal. Sound behaves differently too. In fog, high-frequency sound is dampened slightly, and the thick air feels quieter. Footsteps echo softly. Distant sirens become muted. Even the hum of the city seems wrapped in cotton. Urban fog can be influenced by the shape of streets and the flow of air between buildings. Tall structures create channels where wind speeds up or slows down. Fog may gather in sheltered corners where air is calm, then thin out where a breeze slips through. In some places, it pools low. In others, it lifts and swirls. It becomes almost alive in its movement. Not fast, not restless, but responsive. There is something gentle about fog in a city. It softens hard edges. It quiets the sharp geometry of steel and stone. It makes the world feel smaller, more intimate, as though the city has stepped back from its usual brightness and chosen to whisper instead. And perhaps that is the true magic. Fog transforms the urban environment into something quieter than itself. The streets still exist, the towers still rise, but their presence feels less demanding. The city becomes a dreamscape of softened lights and slow shadows, where even the busiest place can feel calm. Urban fog is shaped by concrete, guided by architecture, and made possible by the same simple balance of temperature and moisture. It is, thus, atmosphere speaking in the language of streets, mist among skylines, a hush drifting between lamplight and alley, a quiet reminder that even in the heart of human-built worlds, the sky still finds ways to breathe softly. As dawn breaks, fog glows. There is a special kind of beauty that belongs only to the moments between night and morning, when the world is still half asleep, and the sky begins to brighten with the gentlest colours. Fog, in this hour, becomes something luminous. It is no longer just a veil, it becomes a canvas. Suspended droplets fill the air like tiny floating mirrors. Each one is so small that it does not fall quickly. Instead, it drifts, held in place by the quiet stability of early morning air. When sunlight first appears, low on the horizon, its rays pass through this misty layer at an angle. The light must travel farther through the atmosphere than it does at midday. And along the way, shorter blue wavelengths scatter away, leaving warmer tones behind: gold, amber, soft rose. This is why sunrise feels warm, even when the air is cold. And when fog is present, those warm tones are amplified. The droplets scatter the light in all directions, diffusing it into a gentle glow. Shadows soften. Contrast fades. The world becomes a watercolor painting of pale brightness and muted shapes. Streetlights dim, overwhelmed by morning. Trees appear as silhouettes, their outlines blurred. Hills in the distance dissolve into layered shades of grey and honey. Sometimes, you may see beams of light cutting through the fog, visible shafts stretching between trees or buildings. These are called crepuscular rays. They appear when sunlight is partially blocked by objects, creating alternating bands of light and shadow. Fog makes these rays visible by scattering the sunlight toward your eyes. It is as though the dawn is drawing lines across the air itself. Halos may form too, around the sun or around a bright lamp lingering in the mist. You might see a faint glowing ring. This happens because light interacts with droplets, bending and scattering in a way that produces a soft circle. Everything becomes gentler. Even the transition from night to day feels slower in fog. The sun rises, but its brightness is filtered. Instead of sharp morning light, the world receives a gradual unfolding. Fog welcomes the sun in quiet ceremony. Scientifically, the fog begins to change as the ground warms. As sunlight touches the surface, the air near the ground warms as well. Warmer air can hold more moisture, so droplets begin to evaporate. At first, the fog thins slowly. It lifts in patches, leaving pockets of clarity. Sunlight breaks through in shimmering bursts. The mist drifts upward, becoming less dense. Eventually, the veil dissolves completely, returning to invisible vapor. But before it disappears, fog offers one last gift: the golden hour, a dreamy interplay of shadow and shine, a moment when light is not harsh, but tender, when the world looks softened, as if seen through half-closed eyes, when the atmosphere turns ordinary streets, fields and forests into something cinematic. And as we hover here between darkness and day, we are reminded that fog is not only a weather phenomenon, it is a mood of the planet, a quiet collaboration between moisture and cooling, between night's calm and morning's first light, a glowing farewell to the night, a golden welcome to the dawn. Fog can feel permanent while you are inside it. The world is hushed, edges are softened, distance is reduced to suggestion. It seems as though the mist has settled in for the day, content to linger without urgency. And then, almost suddenly, it is gone. A hillside that was hidden reappears. A skyline sharpens. A road stretches clearly ahead once more. The transformation can feel like a trick, as if the atmosphere has pulled back a curtain in a single motion. But fog does not truly vanish in an instant. Its disappearance is a quiet unraveling, guided by the same gentle forces that formed it. At the heart of fog is saturation, air cooled to its dew point, allowing water droplets to remain suspended. To dissolve fog, the atmosphere simply needs to reverse that balance. The most common visitor in this process is sunlight. As morning advances, solar radiation warms the ground. Surfaces that cooled overnight begin to regain heat. The air touching those surfaces warms as well, and warmer air can hold more water vapor invisibly. As the temperature rises above the dew point, droplets begin to evaporate. Not all at once, but gradually, molecule by molecule. You might notice thinning first. The mist becomes less dense. Light penetrates more easily. Shapes begin to re-emerge in faint outline. The fog lifts from the ground, becoming patchy. This lifting is often called burning off, though there is no fire involved, only warming and evaporation. A slow return of water, droplets to invisible vapor. Wind can play its part too. A gentle breeze introduces mixing. Drier air from above may blend downward. Moist air near the surface may rise. This vertical mixing disrupts the stable layer that allowed droplets to remain suspended. Fog prefers stillness. When the air begins to move, the delicate balance shifts. Sometimes the change feels sudden because the final threshold happens quickly. Once enough warming or mixing has occurred, the remaining droplets evaporate in rapid succession. The veil thins, and then clarity returns, like a forgotten dream slipping away as you wake. But the water has not disappeared. It has simply changed form. The droplets that once scattered light and softened sound now exist again as vapor, transparent and unseen. The moisture remains part of the atmosphere, waiting for another quiet evening or cooling surface. There is something poetic about this transition. Fog teaches us that visibility is temporary, that what appears solid and present can dissolve, gently, without drama, that the atmosphere is always in motion, even when it feels still. And perhaps that is why its disappearance feels so intimate. One moment, you are wrapped in mist. The next, you are standing in open air, sunlight touching your face. A soft disintegration, a lifting of silver threads from field and forest. No rush, no rupture, just warmth increasing, air stirring, droplets letting go of their suspended state. The disappearing fog trick is not magic. It is balance restored. And as we drift forward, we'll discover that sometimes, even after the fog fades, it finds its way back again, as if unwilling to leave the stage entirely. Some mornings unfold in layers. Fog greets the dawn, glowing softly in early light. Then sunlight strengthens, warming the ground, thinning the mist. Clarity returns. The day seems settled. And yet, later, perhaps toward evening, perhaps after a passing cloud cools the surface, the fog returns, like a lullaby replayed. Fog is not a single event. It is a rhythm, a response to changing surface conditions and shifting airflows. When the delicate balance between temperature and moisture tips toward saturation, mist forms. When that balance shifts away, it dissolves. But balance can tip more than once. Imagine a calm autumn morning. Radiation fog formed overnight as the ground cooled and air reached its dew point. After sunrise, sunlight warms the surface and the fog gradually lifts. The air temperature rises just enough to move above saturation. By midday, the sky may appear mostly clear, though moisture still lingers invisibly in the air. Now, imagine clouds drifting in during the afternoon, softening the sun's warmth. Or perhaps the wind becomes calm again as evening approaches. The surface begins to cool once more. If temperatures fall back toward the dew point, saturation can return, and with it, fog. This recurring fog often appears thinner than before, a gentler echo of the morning's veil. It may form in low spots first, or along rivers and fields where moisture remains abundant. In coastal regions, advection fog may move in and out with subtle wind shifts. A breeze from the sea brings mist ashore. A change in direction carries it back over water. The pattern can repeat over hours or days, like breath moving in and out. The atmosphere is rarely static. Even when the sky looks steady, temperatures fluctuate, surfaces warm and cool, air layers mix and settle. Each small adjustment influences whether moisture remains invisible or gathers into droplets. Recurring fog is a reminder that weather is a process, not a single moment. It is an unfolding conversation between land and air. Sometimes the second arrival feels softer, less dense, more fleeting, as though the fog itself remembers its earlier visit and chooses to linger only briefly. Other times, it returns stronger, especially if moisture has increased through the day, perhaps from evaporation or nearby water sources. And so, the cycle continues. Mist to clarity, clarity to mist, each time shaped by subtle changes in temperature, humidity, and airflow. There is comfort in this repetition. Fog does not hold on to the world tightly. It comes and goes without resistance. It forms when conditions invite it. It leaves when they change. And if the invitation returns, so does the mist, a loop of silver and air, a rhythm of appearance and retreat, like a lullaby replayed in softer tones each time. In this gentle cycling, we see the atmosphere's patience, its willingness to repeat a process as often as balance allows. And as we drift onward, we carry that rhythm with us. The knowledge that fog is never truly final in its departure. It may simply be waiting for the next quiet cooling to return once more. Fog is not only something we see, it is something we measure. In meteorology, visibility has a quiet definition: the greatest distance at which an object can be clearly identified and recognized against the background. It is not simply about shapes appearing faintly. It is about clarity, recognition, the ability to distinguish one form from another. But tonight, we will let the numbers soften into images. On a clear day, visibility may stretch for miles upon miles. Distant hills stand sharply against the sky. Buildings on the horizon appear distinct and steady. As moisture gathers in the air, perhaps as haze, perhaps as thin mist. Visibility begins to shorten. 1 mile. Imagine standing at the edge of a wide meadow. A lone tree rests in the distance. At 1 mile, you can still see its trunk, its canopy, its posture against the sky. Details soften slightly, but the tree remains recognizable. 1/2 mile. Now the tree becomes more of a silhouette. Its leaves blend together. Its edges blur. You know it is a tree, but the texture is gone. 1/4 mile. The tree fades into suggestion. You may see only its darker mass against lighter fog. Recognition requires attention. The world feels smaller. In meteorological terms, dense fog is often defined when visibility drops below 1/4 mile. At that threshold, distance contracts dramatically. The far edge of a field disappears. A stretch of road ahead becomes uncertain beyond a short span. And yet, even in what is called zero visibility, the world is not erased. It is simply wrapped in uniform brightness. Whiteout conditions, more common in heavy snow but possible in thick fog, occur when scattered light eliminates contrast almost entirely. Without shadows or edges, the eye struggles to perceive depth. The horizon dissolves into sameness. But fog rarely arrives all at once. It thickens gradually, like a curtain being drawn inch by inch. Visibility shifts in layers. One moment you can see the end of the street, the next only halfway. Meteorologists measure visibility using landmarks or instruments that detect how much light is scattered by particles in the air. The more droplets present, the more light scatters, and the shorter the visible distance becomes. Each droplet bends and redirects light slightly. Millions of them together create a luminous barrier, not solid, not opaque, but diffusive. Visibility is not just about obstruction. It is about scattering. The language of visibility turns numbers into atmosphere. 1 mile becomes the shadow of a tree. 1/4 mile becomes the edge of memory. 0 becomes a field of glowing white where shapes hide softly within brightness. There is something intimate about limited visibility. When the world narrows, attention turns inward. Sounds feel closer. Light feels nearer. The vastness of distance shrinks into a quiet circle around you. Fog teaches us that clarity is relative. That space can expand and contract without moving at all. That perception depends on tiny droplets suspended in air. And as we drift into our next chapter, we'll explore how those same droplets interact with beams of light, especially when headlights cut through the mist, turning visibility into glowing tunnels of softened physics. Driving through fog can feel like entering a dream. You turn on your headlights, expecting clarity, and instead, the light blooms outward. Halos form. The air itself seems illuminated. The road ahead glows softly, as though you are traveling through a tunnel of mist. This effect is not magic. It is physics, made visible. Fog consists of countless tiny water droplets suspended in air. Each droplet is large enough to scatter light efficiently. When a beam from your headlights strikes these droplets, the light does not pass straight through. It bends, it reflects, it scatters in many directions at once. Some of that scattered light travels back toward your eyes. This backward scattering creates glare, a bright, diffuse glow that seems to hang in front of you. Instead of lighting the road clearly, part of the beam illuminates the fog itself. That is why high beams can sometimes make visibility feel worse in fog. Their stronger, higher angled light encounters more droplets at eye level, increasing the amount of backscatter. The result is a brighter wall of mist. Lower beams aim closer to the ground, reducing the angle at which light scatters back towards the driver. The road may appear clearer because less light is reflected directly into your line of sight. But even without driving, you can see this effect in a simple street lamp. In clear air, a streetlight shines with a defined edge. In fog, the same lamp develops a halo, a glowing sphere around the source. The droplets scatter light outward in all directions, softening the boundary between brightness and darkness. This scattering follows principles known as me-scattering, a type of light interaction that occurs when particles are similar in size to the wavelength of visible light. Fog droplets are perfect for this. Instead of favoring one color strongly over another, they scatter all visible wavelengths fairly evenly. That is why fog appears white or pale grey, and why headlights bloom into white halos rather than coloured rainbows. As you move through fog, your headlights illuminate droplet after droplet. Each one becomes a tiny lens, redirecting light gently. The combined effect creates glowing orbs, fuzzy edges, and luminous tunnels. It feels almost cinematic. The world beyond the beam remains hidden, but the space within it feels intimate and enclosed. Trees appear suddenly at the edge of light. Reflective signs shimmer softly. The road markings glow faintly beneath the haze. There is something peaceful in this softened brightness. Light does not pierce sharply. It diffuses. It spreads. It lingers in the air before fading into shadow. Fog reminds us that light is not simply a straight line. It is a wave interacting with matter, shaped by droplets too small to see individually. And when those droplets gather in the night, they turn ordinary beams into glowing constellations close to the ground. Not just visibility, but illumination transformed. Physics softened for sleep. Fog has a way of making even the busiest places feel still. An airport is usually full of motion, rolling luggage, glowing departure boards, engines humming, voices echoing through wide halls. It is a place built for travel, for distance, for speed. But when fog arrives, the airport becomes something else. Quiet, paused. Tonight, we step onto a fog-bound runway where the sky feels close enough to touch. The lights along the tarmac glow like tiny stars pressed into the ground. The control tower stands tall, watching over a world that has suddenly shrunk. Fog is simply a cloud that has lowered itself to the surface. And when that cloud settles over an airport, it changes everything about flight. Pilots do not only need airspace, they need sight. They need to see the runway lights, the markings on the ground, the end of the strip stretching into the distance. They need clear reference points during takeoff and landing, especially in the final moments when wheels meet Earth. Meteorologists measure this carefully. Visibility becomes the language of aviation. At airports, visibility is often described in terms of how far a pilot can see along the runway. This is called Runway Visual Range, or RVR. Instruments placed along the runway measure how much light is scattered by fog droplets, calculating the distance at which runway lights can still be distinguished. Even if the sky above is clear, a shallow layer of fog at ground level can reduce RVR to almost nothing. The runway might still exist, solid and ready, but the view down it becomes a soft wall of grey, and so flights wait, not with panic, not with urgency, but with patient caution. The atmosphere is not hostile, only opaque. It is not stormy, only quiet. The airport becomes a world grounded by clouds. In the terminal, passengers may sit, with warm drinks, watching through large windows as fog presses against the glass. The shapes of planes appear faintly, then disappear again. A tail fin emerges like a ghostly sail. A set of landing lights glows, then fades. Outside, ground crews move slowly, guided by signals and lights. Vehicles drive carefully along marked paths. Everything becomes deliberate, because fog reduces the visual cues that humans rely on. Even the simplest actions require attention. Pilots are trained for this. Modern aviation includes systems that allow landing in low visibility using instrument approaches. These systems rely on radio signals and precise guidance rather than sight alone. Certain airports have advanced instrument landing systems, allowing aircraft to descend through fog with careful accuracy. Still, there are limits. Even the most sophisticated technology cannot erase the reality that at some point, pilots must see the runway to land safely. That moment, called minimums, is like the final threshold. If the runway is not visible by then, the aircraft must go around, rising back into the foggy sky to try again, or divert to another airport. And so, fog can delay flights. It can reroute journeys. It can keep aircraft circling patiently above the clouds, waiting for a break in the veil. But the fog itself remains calm. It does not rage. It does not threaten. It simply sits. Often, airport fog forms overnight as radiation fog, when the ground cools and moist air reaches saturation. Airports are frequently built on flat, open land, the kind of terrain where fog can spread easily and evenly. By morning, the runway may be wrapped in a smooth layer of mist, while the rest of the city nearby remains clear. Eventually, sunlight begins to warm the surface. Wind may stir gently, the dew point balance shifts, and droplets evaporate. The fog lifts like a slow curtain. The airport awakens. Engines start. Taxi lights line up. Runways stretch outward again, visible and inviting. But until then, everything waits. A world paused. Sky waiting for sky. An airport grounded by the softest kind of cloud. In thick marine fog, the world becomes quieter, and sound becomes more important. Along the coast, where cliffs meet waves and harbours cradle sleeping boats, fog can arrive like a silent tide. It rolls in from the sea, draping shorelines in pale mist, softening every edge until land and water feel stitched together. And when visibility fades, the night begins to sing differently. Tonight, we listen. Far out over the water, a lighthouse beam sweeps slowly through the fog. Its light does not travel far. Instead, it glows softly, diffused by droplets, creating a hazy halo that seems to hover in place. The beam becomes a gentle pulse rather than a sharp line. Ships once relied on that light as a guide. But in heavy fog, light alone is not enough. Fog scatters light, bending it in every direction. A bright beacon becomes blurred. A distant shore becomes invisible. And so, coastal regions developed another language, one that does not depend on sight. Sound. Foghorns exist because sound waves travel differently through moist air. While fog droplets themselves do not carry sound in a magical way, the damp, stable air that accompanies fog can allow sound to propagate smoothly over water, especially at night. The atmosphere becomes layered and calm. Without strong winds or turbulence, sound can travel farther than usual, gliding along the surface of the sea. And so, in thick marine fog, foghorns sing, a long, low call, a deep note that seems to come from nowhere and everywhere at once. It rolls through the mist in slow pulses, echoing off cliffs and slipping between docks. The sound is not sharp. It is rounded, softened by distance and moisture. To sailors, These calls are not frightening. They are comforting. They are steady markers in a world without sight. Each horn has a pattern, a rhythm of blasts and pauses that identifies a specific location. One harbour might call in a long tone every 30 seconds. Another might answer in 2 shorter notes. In this way, the coastline speaks through sound, a map made of echoes. Standing on shore, you might hear the horn before you see anything at all. The sea itself remains hidden behind the veil, but the sound confirms its presence. The fog becomes not emptiness, but atmosphere, full of gentle signals. Even waves sound different in fog. The crashing of surf becomes muted, as if wrapped in cloth. Distant boat engines hum softly, then fade. Seagulls call faintly overhead, their shapes unseen. The entire coast becomes a soundscape, and there is something deeply soothing about it. Foghorns are slow by design. Their low frequency travels far, cutting through mist more effectively than higher tones. Their rhythm is unhurried, steady as breathing, a pulse in the fog, a lullaby for ships. As night deepens, the fog may thicken. The lighthouse glow becomes dimmer. The horn continues its patient song, repeating again and again, never rushing, never changing. And then, sometime before dawn, the air shifts. Perhaps the wind turns slightly. Perhaps the temperature rises. The fog begins to thin, retreating back toward the sea or dissolving into invisible vapor. The horn grows quieter, then unnecessary. But for a while, in the heart of marine mist, the coast speaks softly through sound. A beacon you can hear, a steady voice in the grey, a reminder that even when sight disappears, the world still offers gentle guidance, through echoes, through rhythm, through the calm breathing of the sea. Soft as breath, morning fog settles over grass. It arrives in the hours when the world is still asleep, when the sky is pale and quiet, and the air feels untouched. Before sunrise, the land has spent the entire night releasing its warmth into the open atmosphere. The ground cools steadily, almost tenderly, and the thin layer of air resting against it cools as well. This is where morning fog is born. In wide meadows and open fields, the process feels especially gentle. Grass holds onto the coolness of night, and moisture lingers close to the surface. If the air cools to its dew point, that invisible threshold where vapor becomes droplets, the atmosphere reveals itself. A mist forms. At first, it is faint, a soft blur just above the ground. But as the minutes pass, the fog thickens into a silvery blanket that rests low across the meadow, hugging the land like a quiet secret. The world becomes smaller. Distant trees fade. Fence posts become ghostly outlines. Even the horizon dissolves into pale grey, as though the meadow has been wrapped in cotton. And everywhere, dew begins to gather. Dew is the sister of fog, formed by the same gentle physics. When surfaces cool below the dew point temperature, water vapor condenses directly onto them. Grass blades become jeweled with droplets. Petals collect tiny beads that glimmer faintly in early light. Spiderwebs catch moisture and hold it like lace. In the fog, these droplets feel almost inevitable. The air is saturated. Everything is damp with quiet abundance. You might imagine walking slowly through the meadow, your steps muffled by wet grass. Each breath feels cool and clean. The fog swirls lightly around your ankles, disturbed only by your movement. There is no wind here, only stillness. This is why morning fog feels so peaceful. It forms in stable conditions, calm air, clear skies, gentle cooling. The atmosphere is resting. The earth is resting. Even the birds have not yet fully awakened. Then, slowly, dawn begins. The sky lightens from black to deep blue, then to soft grey. The first hint of sunlight touches the upper edges of distant trees. Fog responds immediately to light, not by fear, but by quiet transformation. Sunlight warms the ground warms the air rises slightly above the dew point. Droplets begin to evaporate. Fog does not disappear like a door slamming shut. It lifts like a curtain drawn upward. At first, it becomes patchy. Clear pockets open in the mist, revealing small islands of meadow. Then, the fog thins into wisps, drifting upward in pale ribbons. It clings briefly to shaded hollows and low dips in the land, where coolness remains longer. The rising sun turns the fog luminous. Light scatters through suspended droplets, creating a soft glow that feels almost golden. For a few minutes, the meadow looks like a painting: blurred edges, glowing air, gentle shadows. This is a chapter of beginnings, because morning fog is a reminder that each day begins quietly. Before the noise of traffic, before voices fill the air, before sunlight fully claims the world, the atmosphere offers a moment of softness. A meadow breathing mist, grass glittering with dew, a hush that feels like a fresh page. And as the fog lifts, the world awakens slowly, as if it has been gently stirred from sleep, not rushed, not forced, just warmed into clarity. And in that slow transition, we are reminded that even the simplest weather, a low fog over grass, can feel like poetry written by temperature and light. Fog is beautiful. It softens the world, quiets the air, and turns landscapes into dreamlike scenes. But beyond its gentle appearance, fog also has purpose. It is not only atmosphere, it is water. Tonight, we drift beyond the visual poetry and into the quiet work fog does for the planet, its role in climate and hydrology, the slow movement of water through air, land, and life. Fog is made of tiny droplets suspended in the lower atmosphere. And while each droplet is small, together they represent real moisture, water that can nourish ecosystems in subtle, steady ways. In many regions, fog is an important source of hydration. Along coastal mountains, for example, moist ocean air drifts inland and rises over slopes. As it cools, it condenses into fog. This fog clings to forests, wrapping leaves and branches in damp air. Droplets collect on needles and foliage, then drip slowly downward. This process is known as fog drip. It is not rainfall, but it can provide significant moisture over time, especially in dry seasons. In places like coastal California, Chile, and parts of Africa, fog drip can sustain plant life when rain is scarce. Trees become quiet collectors. Leaves become surfaces where the sky's moisture gathers. And the forest floor receives water in gentle, continuous drops. Fog also shapes microclimates, small localized climates influenced by geography and atmospheric conditions. A coastal area with frequent fog may remain cooler in summer because fog blocks sunlight and reduces heating. This can affect which plants grow, which animals thrive, and how quickly soil dries. Fog can act like a natural shade cloth. It moderates temperature. It smooths extremes. In deserts near oceans, fog can be a lifeline. Certain desert ecosystems rely on fog to provide moisture in environments where rain may fall only rarely. Some plants have evolved to capture fog droplets directly, channeling water down their stems and roots. Even insects and small animals may drink from fog-collected droplets on rocks and leaves. In this way, fog becomes part of the hydrological cycle, the endless circulation of water between ocean, atmosphere, land, and living things. Water evaporates from the sea. It travels as vapor. It condenses into fog. It returns to the land as droplets, not always as rain, sometimes as mist. Fog also influences climate by affecting energy balance. Because it reflects sunlight, fog can cool surface temperatures during the day. At night, it can sometimes trap heat near the ground, reducing how quickly temperatures drop. This depends on the thickness of the fog and the layers of air above it. So fog is not only water, it is also a regulator, a gentle thermostat for certain regions. On a global scale, fog may seem small compared to storms or rainfall systems, but its impact is quiet and persistent. It shapes coastal agriculture, influences wildfire risk by maintaining moisture, and supports biodiversity in places where rain is seasonal or unreliable. And perhaps most beautifully, fog teaches us that water does not always arrive loudly. Sometimes it comes as a whisper, a thin veil drifting through trees, droplets forming on leaves, moisture delivered in silence. Fog reminds us that the atmosphere is not only a sky above us. It is part of life's plumbing system, a slow-moving river of vapor and droplets connecting oceans to forests, coastlines to deserts, air to soil. Beyond beauty, fog matters. It nourishes, it moderates, it sustains. A quiet contribution to the rhythms of life, carried not in downpours, but in soft silver breaths. In quiet forests, fog does not simply arrive, it settles in as though it belongs. Beneath tall trees, where trunks rise like columns and branches knit together high overhead, the air feels different, cooler, shaded, layered. Sunlight rarely reaches the forest floor without first passing through leaves, needles, and drifting threads of mist. Tonight, we wander there. The forest canopy acts like a gentle net for fog. When moist air moves through wooded hills or coastal mountains, it cools and condenses among the branches. Droplets gather not only in open air, but directly upon the surfaces of leaves and bark. Fog weaves through branches like breath through lungs. It curls around pine needles, softens their sharp outlines, and beads along spider silk stretched invisibly between twigs. Each strand becomes a necklace of droplets, trembling slightly in the stillness. Moss absorbs the dampness eagerly. Ferns glisten. Fallen logs darken with moisture. Some forests depend on this. In certain coastal and mountainous regions, fog is not merely an occasional visitor. It is a hidden water source, steady, dependable, quiet. When fog drifts through the canopy, droplets cling to leaves and needles. Over time, they grow heavier and fall as tiny drips to the soil below. This is fog drip, a form of precipitation without rain. In redwood forests, for example, fog can supply a significant portion of the moisture trees receive during dry summer months. The tallest trees extend into the fog layer itself, collecting water high above the ground. That moisture travels downward, nourishing understory plants, fungi, and roots. The forest becomes both collector and distributor. Walking beneath such a canopy feels immersive. Light filters through in silver ribbons, diffused by suspended droplets. Shadows soften. The scent of earth and bark deepens. Damp soil releasing a fragrance that feels ancient and grounding. Sound behaves gently here. Footsteps are cushioned by wet leaves. Distant birdsong carries softly through layered air. Even the smallest rustle seems magnified in the hush. Fog in the forest moves slowly. It does not rush between trunks. It lingers, shifting almost imperceptibly. One moment a clearing appears faintly ahead. The next, it is wrapped again in pale mist. The boundary between air and land blurs. Moisture coats every surface, and it becomes difficult to say where atmosphere ends and forest begins. Leaves hold droplets. Bark darkens with dampness. Fern fronds collect beads of water that slide quietly toward the ground. In this environment, fog feels alive. Not in motion alone, but in purpose. It cools the air beneath the canopy, moderating temperature swings. It reduces evaporation, helping the forest retain moisture longer. It nourishes lichens and mosses that depend on consistent humidity. Each droplet is small, yet together they sustain an entire ecosystem. And then, as sunlight strengthens or winds shift, the fog begins to lift. It thins upward, rising through branches like smoke, drifting toward the sky. Light sharpens, edges return, but the moisture remains, absorbed into soil, clinging to leaves, feeding roots unseen below. Fog becomes part of the forest's heartbeat, a quiet inhalation of moisture, a slow exhalation of droplets. In these places, fog is not an interruption of clarity. It is a rhythm, a soft weaving of air and tree, of vapor and bark, reminding us that forests breathe not only oxygen, but mist. Even deserts, so known for thirst, sometimes awaken beneath fog. It feels almost impossible at first to imagine mist drifting over sand, or droplets gathering on cactus spines. Yet along certain coasts, where cold ocean currents meet warmer air, marine layers form and move inland before sunrise. And for a brief, gentle hour, the drylands soften. Deserts near oceans, like those along western South America, southwestern Africa, and parts of the southwestern United States, experience cool currents offshore. These currents chill the air above them, forming layers of moist marine fog. Carried inland by subtle breezes, the fog creeps quietly across dunes and rocky plains. It arrives before dawn, when temperatures are lowest and the contrast between cool air and land is smallest. The sky remains dim. The landscape waits in silence. Then, gradually, the mist appears. It may begin as a faint haze on the horizon. Then, it thickens into a low cloud hugging the ground. Sand dunes fade into suggestion. Desert shrubs become shadowy outlines. In a place defined by dryness, this moisture feels almost miraculous. Tiny droplets settle on cactus spines and desert blooms. Many desert plants are uniquely adapted to capture this fog. Some have fine hairs or textured surfaces that collect droplets efficiently, guiding water toward stems and roots. Even certain beetles in coastal deserts position their bodies to harvest fog droplets, allowing moisture to roll toward their mouths. The air, for a moment, forgets its arid nature. Instead of hot and dry, it becomes cool and damp. The scent of dust softens. Fine grains of sand cling together slightly, darkened by moisture. Fog in the desert is usually shallow and temporary. As the sun rises higher, the land warms quickly. The thin marine layer loses its cooling influence. Droplets evaporate, returning to invisible vapor. But during its presence, fog offers life-sustaining hydration in places where rainfall may be scarce or seasonal. This phenomenon is sometimes called fog oases, areas where vegetation thrives primarily because of frequent fog rather than rain. Lush pockets of greenery can exist within otherwise stark landscapes, supported quietly by mist. There is something deeply calming about this meeting of opposites. Dryness and dew, sand and silver mist. The desert under fog feels almost dreamlike. The harsh brightness often associated with arid lands is replaced by soft, diffused light. Shadows blur. The horizon disappears into pale grey. Silence deepens. You might imagine walking gently across dampened sand, each step leaving a slightly darker imprint. A cactus glistens faintly. A desert flower holds droplets along its petals like fragile jewels. The fog does not stay long, but it does not need to. Its role is brief yet meaningful, offering moisture, cooling the surface, shaping microclimates in subtle ways. Even the driest landscapes welcome mist. Even the most sun-baked terrain can host a quiet breath of water before dawn. And when the fog lifts, clarity returns with the rising sun. The desert resumes its bright, open character. But somewhere in the soil, in the roots of a plant, in the body of a beetle, the memory of that mist remains. A reminder that dryness and moisture are not enemies, only phases. And sometimes, just before morning fully awakens, the desert inhales silver air and drinks deeply from the sky. High in mountain passes, fog can become thick enough to erase the world. In these elevated places, where roads wind between ridges and valleys, drop away into shadows, atmosphere feels closer than it does at sea level. The sky is not a distant ceiling here. It is something that can brush your face, settle on your shoulders, and wrap the landscape in quiet. Tonight, we drift gently into the hush of mountain fog. In many ways, mountains invite fog. Their slopes guide air upward, and rising air cools naturally as it climbs. This cooling is not sudden or harsh. It is simply the atmosphere responding to lower pressure at higher elevations. As air rises, it expands. As it expands, it cools. If the air is moist enough, that cooling brings it closer and closer to saturation. Eventually, it reaches the dew point. Water vapor condenses into tiny droplets, and fog forms. In a mountain pass, this process can happen quickly. Moist air flowing toward a range may be forced upward by terrain. It cools as it climbs, and the pass becomes a gathering place for cloud and mist. Fog can spill over ridgelines like slow-moving water, drifting downward into valleys and pooling along roadways. Sometimes the fog is thin and the world remains visible in soft outlines. But sometimes the droplets become so dense that visibility collapses. Road lines vanish, peaks disappear, the horizon dissolves. Only whiteness remains. This is what people often call a whiteout. In a true whiteout, there is very little contrast. Light scatters in every direction through millions of droplets. Shadows fade. Depth becomes difficult to sense. Without clear reference points, the landscape feels flattened, as though the world has turned into a blank canvas. And yet, even in this complete veil, the atmosphere is calm. Fog does not roar like wind. It does not strike like hail. It simply envelops. The reason mountain passes are so prone to these conditions is that they combine several fog-friendly elements at once: elevation, cooling, moisture, and confinement. Elevated air is naturally cooler. Mountain passes can trap airflow, channeling moist air through narrow corridors. If the air remains stable and winds are not strong enough to disperse droplets, the fog thickens and persists. Sometimes, mountain fog is connected to low clouds that rest against the peaks. The pass becomes part of the cloud layer itself, not below it, but inside it. Walking through such a place can feel like stepping into the sky. The air is damp. Each breath feels cool. Surfaces grow wet with condensed moisture. Rocks darken. Pine needles glisten. The scent of cold stone and evergreen becomes stronger, carried through saturated air. Sound changes too. Fog absorbs and scatters sound waves, making the environment feel quieter. Distant noises vanish. Even your own footsteps seem muffled. In that silence, the world feels strangely intimate. A few feet ahead, becomes the only visible space. The rest of the landscape disappears into pale brightness. It is as if the mountain has closed its eyes. But meteorologically, nothing mysterious is happening. It is simply condensation, water vapor cooled into droplets, suspended in air. The same process that creates gentle meadow fog at dawn can create complete whiteout fog in a mountain pass. The difference is the setting: higher elevation, colder air, and the way terrain guides and traps moisture. Eventually, conditions shift. Perhaps the wind strengthens, stirring the air and breaking the stable layer. Perhaps sunlight warms the slope, lifting the fog upward. Or perhaps the moist airflow changes direction, leaving the pass drier. The veil begins to thin. The outlines of trees return. Road markings reappear. Peaks emerge, faint at first, then sharp, and suddenly the world feels vast again. But for a time, in the quiet heights, fog creates a hush so complete it feels like walking inside a cloud. A white silence, a mountain pass turned into sky. A reminder that the atmosphere is not always above us. Sometimes it surrounds us completely. In very fine droplets, light bends softly, not with the bold brilliance of a storm rainbow, but with a gentler hand, like a whisper traced across the air. This is how fog bows are born. Fog bows are rare, delicate arcs that appear in misty conditions when the sun is low, and fog droplets are especially small. They look like rainbows, but their colours are muted, sometimes nearly absent, leaving a pale, ghost-like band of white light stretching across the fog. Tonight, we stand quietly in a misty meadow where the world is still wrapped in soft grey. The grass is wet with dew. The air is cool and calm. The sun rises slowly behind us, just above the horizon, sending light forward into the mist. And then, almost gently, an arc begins to form. A faint curve in the fog, a bow made of light. To understand why it looks so different from a normal rainbow, we need to think about droplets. A classic rainbow forms when sunlight enters larger raindrops, bends as it passes through, reflects off the inside surface, and bends again as it exits. This refraction separates white sunlight into its different wavelengths, producing the familiar spectrum of red, orange, yellow, green, blue, indigo, and violet. Raindrops are large enough for this separation to be crisp and distinct, but fog droplets are much smaller, often less than 1/10 of a millimeter in diameter. They are tiny, almost weightless beads suspended in air. When sunlight interacts with droplets this small, diffraction becomes important. Diffraction is the gentle spreading of light waves as they pass around small objects. Instead of producing clean bands of colour, the light scatters and overlaps. The wavelengths blend together again. The result is an arc that is wide, pale, and nearly colourless. A rainbow without song, a rainbow whispered. Sometimes, if you look closely, you might see faint hints of colour, a soft reddish edge on the outside, a faint bluish tone on the inside. But mostly, the fog bow appears white, glowing softly against the grey mist. Its beauty is subtle. It does not demand attention. It invites stillness. Fog bows are often seen when the sun is behind the observer, shining into fog or very thin cloud. They can also appear around the shadow of an airplane on clouds, a related phenomenon called a glory. But in the meadow, the experience feels almost personal. The arc appears as if drawn by dawn itself. It floats ahead of you, suspended in mist, delicate as breath on glass. The air feels luminous. Even the fog seems to brighten slightly, as if responding to the presence of this pale curve. Fog bows remind us that the atmosphere holds countless hidden optical wonders. Light is always bending, scattering, reflecting, interacting with droplets and crystals. We simply don't always notice. But when conditions align, low sun, fine droplets, calm air, the world offers a quiet reward. A bow of silver light, a gentle echo of the rainbow, softened by fog. And like fog itself, the fog bow does not last long. As the sun rises higher, the angle changes. As droplets evaporate, the mist thins, the arc fades. It disappears without drama, leaving only dew-covered grass, pale morning light, and the lingering feeling that you witnessed something rare and delicate. A rainbow not shouted across the sky, but breathed into it. A fog bow, a curve of quiet wonder. Fog carries smell differently. You may have noticed it on certain mornings, stepping outside into mist and suddenly sensing the world more vividly. The fragrance of damp earth, the sharp green scent of leaves, the faint salt of the sea, even the distant aroma of wood smoke or wet pavement. Fog does not create these scents, but it changes the way they travel. Tonight, we breathe slowly into this quiet mystery, the way moisture in the air can turn fragrance into something closer, richer, more present. Smell is carried by tiny airborne molecules. When something has a scent, soil after rain, pine needles, ocean spray, it releases volatile compounds into the air. These compounds drift invisibly until they reach your nose, where receptors recognize them and translate them into sensation. In dry air, many scent molecules disperse quickly. They spread out and dilute. Wind may scatter them, and without much moisture, the molecules have less to cling to. But fog is different. Fog is made of suspended water droplets, and those droplets act like tiny carriers. Many scent molecules dissolve into water easily, or attach themselves to moist surfaces. When fog is present, fragrance can become trapped in the lower layer of air, lingering rather than drifting away. The atmosphere becomes a gentle bowl, holding scent close to the ground. This is especially true when fog forms under calm conditions. With a little wind to mix the air, smells remain concentrated near their source. The air feels still, and the world feels closer. Dampness also changes the landscape itself. Leaves and bark absorb moisture. Soil darkens and releases its earthy aroma more strongly. The scent known as petrichor, the fresh smell of damp ground, becomes more noticeable when moisture activates compounds released by plants and microbes. Fog doesn't need rain to awaken this. Sometimes the mere presence of moisture in the air is enough to enhance the earthy fragrance of a forest floor. Near the sea, fog can carry salt. Sea spray contains tiny particles of salt that become suspended in the air. When fog drifts in, these particles and the moisture surrounding them create a soft marine scent. Even inland, the fog can bring the ocean's presence, as though the water has travelled invisibly into the streets. In cities, fog changes scent too. Wet concrete, metal railings, old brick walls, each releases subtle aromas when coated with moisture. The smell of rain-soaked pavement becomes stronger in fog, even if no rain has fallen. The air feels heavier, saturated, full of quiet detail. There is also a gentle chemical reason that smell feels more vivid in humid air. Moisture helps scent molecules dissolve and reach the receptors in your nose more effectively. Dry air can dry out nasal passages slightly, reducing sensitivity. Humid air keeps them comfortable, allowing aromas to be detected more clearly. So fog, in a way, sharpens the sense of smell, not through intensity, but through closeness. A distant pine tree becomes more fragrant. A damp field smells sweeter. Fallen leaves release a faint, woody perfume. Even the cold mineral scent of stone becomes noticeable. And in this way, fog becomes more than a visual phenomenon. It becomes an atmosphere you can taste with breath. The scent of fog is the scent of everything the fog touches. Earth, leaves, sea salt, moss, wood smoke, wet grass. It is the world's fragrance gathered gently and held close, like a blanket. And as we inhale slowly, we feel that fog is not emptiness. It is fullness, air filled with water droplets, air filled with memory, air filled with the subtle perfume of the landscape. The science of scent becomes part of the atmosphere's embrace, a quiet reminder that sometimes the world smells more alive when it is wrapped in mist. In mist, sound travels in curious ways. Sometimes it seems to carry farther, as though the fog itself is delivering it gently across the landscape. Other times, sound feels muted and close, softened like fabric pressed against a speaker. A distant train, a buoy bell, a single footstep on wet pavement. Tonight, we drift into the acoustics of fog, the way saturated air shapes vibrations and turns noise into lullaby. Sound is a wave, moving through air as pressure changes. It travels by vibrating molecules, pushing them together, then letting them spread apart, creating a ripple that moves outward. In dry air, sound travels cleanly, but it can also be scattered by turbulence, wind shifts, and temperature differences. The atmosphere is rarely uniform. It is layered, restless, always mixing. Fog, however, often forms under stable conditions. Calm air, light wind, even temperatures near the surface. These conditions can allow sound to travel smoothly without being disrupted by turbulent mixing. When the air is still, sound waves are less likely to be broken apart. This can make distant noises seem clearer. But fog also contains droplets, tiny suspended particles of water. These droplets can absorb and scatter sound energy, especially higher frequency sounds. That means sharp, crisp noises may become softened, while lower tones continue to travel. This is why a foghorn is so low and deep. Low-frequency sound waves have longer wavelengths, allowing them to pass through misty air more effectively. They bend around obstacles, roll across the water, and travel far. High-frequency sounds, like a bird chirp or a sharp clang, may fade more quickly, so fog shapes sound into gentler tones. Even a city becomes quieter under fog. Traffic hum turns softer, voices lose their edge. The world feels wrapped in hush. There is another layer to this: temperature. Fog often forms when the ground is cooler than the air above it, creating a temperature inversion. In an inversion, cooler, denser air is trapped near the surface beneath warmer air. Sound behaves differently in an inversion. Instead of rising and dispersing upward, sound waves can bend back downward toward the ground. This effect can make distant sounds travel farther and seem louder than usual. A train miles away may sound close. A ship bell may echo strangely through the harbour. A dog bark might drift across fields with unusual clarity. Fog, calm air, and inversion, layers together, create an atmosphere where sound becomes both softened and amplified, quieter in texture, but farther in reach. And that combination is what makes fog feel so dreamlike. You might hear something and not know where it comes from. The source is hidden in mist, but the sound arrives gently. Anyway, it feels as though the fog itself is speaking. The way sound fades also changes. In clear air, sound has crisp beginnings and endings. In fog, echoes linger slightly, blurred by the dampness. A horn call stretches out, dissolving slowly rather than cutting off sharply. Even footsteps can feel different, muffled by wet ground, cushioned by quiet air. The entire soundscape becomes rounded. No harsh edges, no sharp clarity, just gentle vibrations moving through dense, moisture-filled air. And perhaps this is why fog feels so peaceful. It does not only hide the world visually, it softens the world acoustically. It takes the sharpness out of distance. It turns far-off noises into low, steady murmurs. It creates a kind of atmospheric blanket that wraps around both sight and sound. In fog, the world becomes a quiet instrument, a buoy bell ringing softly in grey air, a train whispering beyond the horizon, a single footstep fading into mist. And as we listen closely, we realize the fog is not silence. It is sound made gentle, a lullaby written in vibrations, a reminder that even the air can shape the music of the night. Under a full moon, fog does not look white. It looks like something softer, a pale glow, almost bluish, drifting through the darkness as if the night itself has become luminous. The world is quieter than usual. Streetlights feel distant. Stars fade behind the mist. And yet, the fog seems to shine on its own, lit gently from above. Tonight, we walk beneath this quiet illumination. Moonlight is sunlight, reflected. It begins as bright solar rays striking the moon's surface, bouncing back toward Earth in a softened form. By the time it reaches us, it is far dimmer than daylight, but still strong enough to paint landscapes in silver. When fog is present, that silver light changes shape. Fog is made of countless tiny droplets suspended in air. Each droplet is like a miniature lens, scattering light in many directions. Under daylight, this scattering creates a bright white haze. But at night, under moonlight, the scattering is gentler and the colors shift. Our eyes perceive light differently in darkness. In low light, the rod cells in our eyes become more active, and they are more sensitive to blue-green wavelengths. This is why moonlit scenes often appear bluish, even though the moon's light is essentially white. So, when moonlight scatters through fog, the fog takes on that cool tone, a faint blue glow. It is not bright, but it is present, like mist illuminated from within. In such conditions, shadows soften almost completely. Normally, moonlight creates sharp contrasts, especially in clear air. Trees cast long dark lines across the ground. Buildings appear crisp and angular. But fog scatters the light, spreading it out and reducing contrast. Instead of sharp shadow edges, everything becomes smooth. The world feels suspended. Distance becomes difficult to judge. A fence may appear closer than it is. A tree may look like a silhouette floating in grey-blue air. The horizon dissolves entirely, leaving only layers of pale mist and darker shapes. Walking through moonlit fog feels like stepping into a dream that has slowed down. The air is cool. Moisture beads faintly on your skin. Each breath is visible, blending with the surrounding haze. The ground may glisten with dew, reflecting the moon's glow in tiny sparks. Even sound seems quieter at night in fog. The stillness that allows fog to form also creates calm air that carries only faint noises. A distant owl call might drift through the mist. A far-off wave might murmur from an unseen shore. And overhead, the moon remains a blurred lantern behind the veil. Sometimes it appears as a soft disk. Other times it becomes a glowing patch, its edges lost to droplets. The light spreads outward, creating a gentle halo that seems to widen and fade into the surrounding sky. This halo is not imagination. It is scattering. The moon's light, redirected by fog droplets, producing a luminous aura. The scene feels cinematic, but the science remains calm and simple. Light meets droplets. Droplets scatter light. Darkness changes how our eyes perceive the colour. And so fog becomes blue. Not truly, perhaps, but in the language of human vision. Night fog also forms differently than day fog. It often develops as temperatures fall after sunset, especially under clear skies and light winds. Cooling air reaches saturation, droplets form, and the veil settles quietly over fields and streets. Under the moon, this fog feels less like weather and more like atmosphere, like a mood the earth wears. And in that mood, the world becomes gentle. The sharpness of daylight disappears. The edges of objects soften. The mind relaxes into the blurred distance. There is nothing demanding your attention, nothing shouting for clarity, only a quiet radiance, only silver blue mist, only moonlight, scattered through droplets, turning the night into a slow, glowing dream. A place where shadows fade, a place where everything feels suspended between worlds. And as we continue onward, we'll drift closer to the droplets themselves, the tiny spheres of water that create this entire glowing veil. Not all fog is the same. Even though fog may look like a single smooth blanket from a distance, it is made of countless droplets, and those droplets are not all identical. Some are larger and heavier. Others are so fine they feel like breath. Tonight, we examine them gently. Each fog droplet begins as water vapor, condensing when air reaches saturation. But for a droplet to form, water molecules need something to gather around, a tiny particle such as dust, salt, smoke, or pollen. These particles are called condensation nuclei. Once water begins to condense, droplets grow by collecting more vapor. Their size depends on many factors: how saturated the air is, how long the fog has been forming, how much moisture is available, and whether droplets collide and merge. In typical fog, droplets range from about 1 to 30 micrometers in diameter. A micrometer is 1/1,000,000th of a meter, far too small to see individually. But together, millions of droplets become visible as haze. Droplet size matters because it shapes how fog behaves. Larger droplets scatter more light and can reduce visibility more quickly. They also tend to settle downward faster due to gravity, though even large fog droplets fall very slowly compared to raindrops. Smaller droplets can remain suspended longer, creating fog that feels lighter and more uniform. This is why some fog feels thick and milky, while other fog feels like a delicate veil. Droplet size also affects how fog interacts with light. When droplets are relatively large, light scattering can create brighter, more opaque-looking fog. Headlights may produce stronger glare. Streetlights may glow intensely with large halos. When droplets are extremely small, the fog may appear more translucent. It may create subtle optical effects, like fog bows, those pale arcs we explored earlier. Brightness and softness are shaped at the microscopic level. Even the feel of fog can change with droplet size. Fine droplets can cling to your skin as a cool dampness. Larger droplets may bead on surfaces more quickly, leaving water on windows, leaves, and road signs. And while fog droplets are too small to fall like rain, they can still contribute moisture. In forests, droplets collect on leaves and drip downward. Along coastlines, they coat rocks and plants. In deserts, they cling to spines and petals. Droplets are not just visual, they are hydrological. The atmosphere becomes a floating reservoir of tiny spheres. Fog density is often described by how many droplets exist in a given volume of air. A thicker fog contains more droplets per cubic centimetre, which means more scattering, less visibility, and a stronger sense of enclosure. But the size. Distribution matters too. A fog made of many tiny droplets may look different than a fog made of fewer, larger droplets, even if both contain similar amounts of water. So fog is not one thing. It is a family of textures, a spectrum of suspended moisture. And the most remarkable part is that these droplets are weightless enough to float, yet real enough to reshape an entire landscape. They drift with air currents, hover in stillness, scatter moonlight, blur city skylines, and soften forest trails. Each droplet is a tiny sphere of water, a miniature world, a bead of atmosphere made visible. And when you imagine millions of them suspended together, you begin to understand fog not as emptiness, but as presence, air filled with countless floating points of liquid, quietly held in balance between falling and staying. This is the science of droplet size, small variations creating vast differences, microscopic spheres shaping the way we see, the way we move, the way we feel the world. And as we drift onward, we'll continue to explore fog not only as weather, but as an intimate part of the atmosphere's gentle artistry. In the coldest places on Earth, fog forms differently. Far north, where winter settles in for long months and temperatures fall far below freezing, the air can grow so cold that liquid droplets are no longer the main players in mist. Instead, the atmosphere fills with tiny ice crystals, delicate, suspended, and shimmering. This is ice fog. Unlike the fog we've wandered through in meadows and along coasts, ice fog forms when air temperatures drop well below freezing, often colder than -30 degrees Celsius or -22 degrees Fahrenheit. At these extremes, water vapor does not condense into liquid droplets. It deposits directly into ice. The process is called deposition. Water vapor changes phase without becoming liquid first. Molecules arrange themselves into crystalline structures, forming microscopic ice particles that float in the still air. These crystals are extraordinarily small, light enough to remain suspended when winds are calm, and calmness is essential here. Ice fog forms most often under stable, windless conditions, when frigid air settles into valleys and towns. In Arctic communities, especially during long winter nights, ice fog can appear almost magical. Streetlights glow through the haze, and instead of soft white halos, the air sparkles. Each tiny ice crystal reflects and refracts light, creating a glittering shimmer. It can look as though the air itself is filled with suspended diamonds. Breath becomes visible instantly. Every exhale releases warm moisture into the bitter air, and that moisture freezes almost at once into ice crystals. Clouds of glittering frost swirl briefly before joining the surrounding fog. The entire world feels crystalline. Cars move slowly through luminous mist. Buildings fade into pale outlines. The sky remains dark for much of the day, and the sun, when it rises, hangs low on the horizon, casting soft amber light through frozen air. Ice fog often forms in valleys where cold air pools, similar to valley fog in milder climates, but colder and more fragile. Human activity can even contribute slightly, as exhaust from vehicles or heating systems releases moisture into the air. In extremely cold conditions, that added vapor can freeze and thicken the fog. And yet, despite its icy nature, ice fog is quiet. It does not fall like snow. It does not accumulate heavily on the ground. It simply hangs, a suspended field of microscopic crystals, each one shaped by temperature and humidity. Sometimes, these crystals can settle gently onto surfaces, forming a fine frost. Branches may appear dusted in white. Metal railings grow delicate fringes of ice. Light behaves beautifully here. Because ice crystals have flat surfaces and structured shapes, they interact with light differently than round droplets do. They can create subtle optical effects, faint pillars of light rising above lamps, or soft glows extending vertically into the sky. Walking through ice fog feels like moving inside a frozen constellation. Each breath glitters. Each step sends faint sparkles into motion. Sound remains subdued, cushioned by the cold, dense air. And then, when temperatures rise even slightly, perhaps to a still frigid but less extreme level, the ice crystals may sublimate, turning directly back into vapor. The shimmer fades, clarity returns, but for a time, in polar regions and high-latitude towns, fog becomes something crystalline. Not droplets, but geometry. Not mist, but suspended frost. A reminder that even in the coldest corners of the planet, the atmosphere continues its gentle transformations. Vapor to ice, breath to glitter, air to light, a frozen haze, a silver shimmer, a landscape where the very air sparkles beneath the stars. When fog meets trees, something quiet begins. The mist that hovers so delicately in open air changes character in the presence of leaves and branches. Droplets that were once suspended begin to gather, cling, and combine. And then, softly, they fall. This is fog drip, water born not from clouds high above, but from mist brushing against the living architecture of a forest. Fog is filled with tiny droplets, each one light enough to float. But when these droplets encounter solid surfaces, pine needles, broad leaves, moss-covered bark, they adhere. Surface tension holds them in place. More droplets arrive. They merge together, forming larger beads of water. Gravity begins its gentle pull. Eventually, a droplet grows heavy enough to release. It falls, not as rain from the sky, but as water distilled from air. In forests that frequently experience fog, this process becomes a significant source of moisture. Coastal redwood forests are one well-known example. During dry summer months, rainfall may be rare, yet fog rolls in from the ocean regularly, drifting through the canopy. The tallest trees intercept the mist. Needles and leaves act like collectors, capturing droplets that accumulate and drip steadily to the forest floor. Over hours, this quiet dripping can equal or even exceed light rainfall. Listen closely, and you can hear it. A soft tapping on leaves below, a faint patter on dry soil, water arriving without a cloudburst. Fog drip is gentle but persistent. It nourishes understory plants, replenishes soil moisture, and supports ecosystems that might otherwise struggle during dry seasons. Mosses thrive in these conditions, absorbing moisture directly from damp air. Ferns unfurl in the cool humidity. Roots draw upon the steady trickle filtering downward. The process is almost invisible unless you pause. Walking through a fog-laced forest, you may feel droplets land lightly on your jacket or hair. You might hear a steady rhythm overhead, even though the sky shows no rain. The fog is doing its quiet work above you. The science behind fog drip is simple. Fog droplets collide with surfaces and coalesce. The structure of leaves and needles increases the efficiency of this capture. Some plants are even shaped to maximize interception. Their forms evolved to gather moisture from mist. Over time, fog drip contributes to the hydrological cycle in subtle but meaningful ways. It represents a pathway for atmospheric water to reach the ground without falling as traditional precipitation. In mountainous and coastal regions, this contribution can be vital. And beyond forests, even shrubs, grasses, and rocky surfaces can collect fog moisture. In certain drylands, plants rely on fog drip as a primary water source. There is something deeply calming about water arriving in this way. No thunder, no downpour, no urgency, just a steady, delicate rhythm. A tap, a pause, another tap. Fog drip reminds us that not all nourishment is dramatic. Some arrives quietly, through patience and accumulation. Droplets that seemed weightless in air become meaningful when gathered together. Mist becomes rain, air becomes water, and the forest listens, receiving each drop with quiet gratitude. As the fog eventually thins and lifts, the dripping slows. Leaves remain damp. The soil holds a little more moisture than before. But for a time, beneath silver canopy and filtered light, water falls from air itself. A quiet rain born from mist. A rhythm softer than rainfall. A reminder that even the gentlest atmospheric moments can sustain entire landscapes. There is a moment in the early morning when fog begins to loosen its hold. It is not abrupt, not dramatic. No sharp line divides mist from clarity. Instead, the transformation happens gradually, a slow softening, a quiet lifting. This is the morning burn-off. Despite the name, nothing burns. There is no flame, no smoke. The phrase simply describes the way sunlight warms the ground, allowing fog droplets to evaporate and return to invisible vapor. At dawn, fog often rests closest to the surface. It may cling to meadows, hover over roads, or pool in valleys. The air is cool, saturated, balanced delicately at the dew point. Then, the sun rises higher. Its rays, angled low at first, begin touching the ground. Soil, grass, rooftops, and pavement absorb energy. Heat spreads outward and upward. The air in contact with these surfaces warms slightly. And when air warms, its capacity to hold water vapor increases. The droplets suspended in the fog no longer need to remain liquid. They begin to evaporate, molecule by molecule, dissolving back into the air. From within the fog, this feels like thinning. The mist becomes lighter. Patches of clarity appear, small at first. You might notice a distant tree emerging, faint but defined. A fence line stretches a little farther than before. Sunlight filters through in brighter beams. As warming continues, gentle currents begin to rise from the ground. Warm air lifts, carrying moisture upward. This vertical mixing breaks apart the stable layer that allowed fog to persist overnight. The fog does not vanish all at once. It rises in soft layers, sometimes forming low, drifting wisps that detach from the ground. It may linger in shaded areas, beneath trees, along riverbanks, in hollows where cool air remains trapped. But overall, it retreats. The process can take minutes or hours, depending on how thick the fog is and how strong the sunlight becomes. On some mornings, the burn-off feels almost magical, happening quickly as the sun clears the horizon. On others, it is patient, unfolding slowly as warmth builds. The soundscape shifts too. As clarity returns, birds become more active. Distant traffic grows louder. The world feels awake again. And yet, the moisture has not disappeared. It has simply changed state. The droplets that once floated visibly now exist again as vapor, transparent, integrated into the atmosphere. They may rise higher and contribute to thin clouds. They may remain near the surface, waiting for another evening's cooling. The burn-off is not an ending. It is a transformation. Fog reminds us that visibility is temporary, and so is its absence. Mist and clarity are phases in a cycle shaped by temperature and sunlight. Standing in that moment of transition feels almost meditative. You watch the veil lift. You feel warmth spreading. You notice shapes returning to full outline. The world does not become louder or harsher. It simply becomes defined again. Edges sharpen, colors brighten, distance stretches outward, and there is comfort in that return. Because the fog did not leave in anger, it did not retreat dramatically. It dissolved gently, as though exhaling one last cool breath before yielding to the day. The morning burn-off is a quiet reminder of balance. Cooling forms droplets. Warming lifts them. A steady exchange between night and day. A soft return from mist to clarity. And as we drift onward, we'll wander into open farmland where fog plays a different role, not only as beauty, but as quiet protection for the land itself. Fields sometimes wake beneath a low cloud. Before sunrise, rows of crops lie hidden under a silver cover, the land wrapped in soft obscurity. From a distance, the countryside looks like a pale ocean stretching gently across rolling hills. This is fog over farmland. It often forms on clear, calm nights when the ground cools steadily and moist air near the surface reaches saturation. Fields, especially those irrigated or recently watered, hold moisture that rises invisibly into the air. As temperatures fall, that moisture condenses into fog. By dawn, crops may be entirely veiled. Cornfields become ghostly silhouettes. Orchards dissolve into faint shapes. Fences fade into mist. And somewhere nearby, a farmer waits patiently. Fog in farmland is not always an inconvenience. In many cases, it provides benefits, subtle but meaningful ones. During cool mornings, fog can protect tender growth from sudden temperature shifts. The layer of mist acts like a gentle buffer, reducing rapid heating when the sun rises. It scatters sunlight, preventing harsh rays from striking delicate leaves too quickly. This soft diffusion of light can reduce stress on plants, especially in early growth stages. Fog also slows evaporation. Moist air decreases the rate at which water leaves soil and plant surfaces. Dew remains longer. Leaves stay hydrated. The ground holds onto its moisture just a little more effectively. Walking through such a field feels serene. Dew hangs heavy on leaves. Spiderwebs stretch between stalks, adorned with tiny droplets. Each step brushes against cool plants, releasing faint earthy scents into the damp air. The fog moves gently among rows, drifting in low swells like quiet tides. In valleys and low-lying farmland, fog may be especially thick. Cool air drains downhill overnight, pooling in basins where crops grow. The landscape becomes a shallow bowl filled with mist. As sunrise strengthens, the same process we explored before begins again. Sunlight warms the soil. Warm air rises. Droplets evaporate. The fog lifts in slow waves, revealing neat rows of green beneath. Barns emerge first as faint outlines, then as solid shapes. Silos stand tall again against brightening sky. Farmers often observe this daily rhythm. They watch for how long the fog lingers, how quickly it burns off, how heavy the dew feels. These small details can signal changes in humidity, soil moisture, and temperature patterns. Fog is not just scenery here. It is part of the agricultural climate. In some regions, consistent morning fog contributes to ideal growing conditions for specific crops. Grapevines, for example, benefit from cool, foggy mornings that preserve acidity in grapes before the warmth of midday arrives. The mist becomes part of the crop's character, and in quieter fields, far from cities, fog makes the land feel timeless. Tractors stand still in silver air, fences stretch into pale distance, birds move through the haze as fleeting shadows. There is no urgency in farmland fog. It rests, it protects, it nourishes, and when it finally lifts, the day begins not abruptly, but gradually, warmed, hydrated, prepared. Fog over farmland is both veil and guardian, a low cloud that shields tender growth from harsh sun, a soft breath over soil and leaf, a reminder that even in places shaped by human hands, the atmosphere continues its gentle partnership with the earth. Mist before labor, silver before gold, and always a quiet beginning to the day's work. Fog has always been more than weather, long before it was measured in miles and meters, before meteorologists described dew point and saturation. Fog lived in the human imagination. It moved through myths, legends, poetry, and paintings as something alive, a messenger, a veil, a doorway. Throughout history, fog has carried symbolism, mystery, transition, the unknown, and tonight we drift gently through those stories. Fog arrives in a way that feels theatrical. It does not announce itself with thunder. It does not demand attention. It simply changes the world quietly, altering the shape of what is familiar. A village becomes distant. A shoreline disappears. A forest path becomes uncertain. In ancient cultures, fog was often seen as a boundary between worlds. It could conceal spirits, hide gods, or mark the passage from one realm into another. In Celtic mythology, mist was sometimes believed to rise from sacred lands, protecting hidden places from ordinary eyes. The veil was not a threat. It was protection. In Japanese folklore, fog is sometimes described as something that carries wandering spirits or reveals the presence of unseen forces. It is soft but powerful in its symbolism, a reminder that not everything in the world is meant to be immediately clear. In Greek and Roman stories, mist often accompanied gods who wished to hide their movements. A fog could cloak a battlefield, soften the sight of mortals, or allow divine presence to pass unnoticed. Fog became a tool of quiet transformation, a way to change reality without changing the world itself. Even in literature, fog often appears in moments of emotional transition. It is used to represent confusion, memory, longing, or the gentle uncertainty that comes before understanding. In Victorian novels, fog frequently drifts through city streets as a symbol of secrecy and complexity. It becomes a character of its own, softening lamps, swallowing footsteps, turning familiar alleys into quiet puzzles. But fog does not only symbolize confusion. Sometimes it symbolizes possibility. In poetry, fog can represent a pause, a moment between what was and what will be. It is the world holding its breath, a landscape waiting to be revealed. Because fog is temporary, it carries the feeling of change. It suggests that nothing stays fixed, that clarity will return, but perhaps in a different form, that the world can shift gently without warning and still remain safe. Fog is the storyteller of transitions. It arrives at dawn and dusk, the times of day most associated with change. It lingers at the edge of seasons, appearing often in autumn when nights grow cooler and the air becomes heavy with moisture. It belongs to thresholds, and humans have always loved thresholds, the places where one thing becomes another. Even paintings use fog to evoke emotion. Artists soften distant hills, blur shorelines, and let mist suggest depth and silence. Fog allows the viewer's imagination to fill in what cannot be seen. It creates space for the mind to wander. Perhaps that is why fog feels so intimate. It doesn't show you everything. It invites you to dream. It makes the world feel like a story in progress. A road disappearing into mist becomes a symbol of journeys not yet taken. A lighthouse blinking through fog becomes a promise of guidance. A mountain half hidden becomes a quiet reminder that there is always more beyond what you can see. And even though we now understand the science, condensation, droplets, saturation, the symbolism remains. Because knowledge does not remove wonder, fog can be both physics and metaphor. It can be droplets suspended in air, and also the feeling of waking slowly, of remembering slowly, of letting the world reveal itself gently, rather than all at once. Tonight, as we drift through fog's history, we see it not as an obstacle, but as a storyteller, a whisper of the unknown, a soft veil that suggests transformation without fear, a quiet revelation waiting behind silver air. Fog does not shout its message, it simply arrives, and changes the mood of everything. And then, when it lifts, the world feels newly seen, as though the story has turned a page. Fog looks pale for a reason. When you step into it, the world does not become dark. It becomes bright in a muted way, a glowing whiteness that softens edges and reduces contrast. Streetlights bloom into halos. The horizon disappears into luminous grey. This is not because fog blocks light completely. It is because fog scatters it. Tonight, we drift into the physics of scattering and let it become poetry. Fog is made of tiny droplets suspended in air. Each droplet is a small sphere of water, often only a few micrometers wide. They are too small to see individually, but together they form a vast, floating collection of surfaces. When light enters this field of droplets, it meets countless tiny boundaries between air and water. And at every boundary, the light changes direction. Some of it passes through, some of it bends, some of it reflects, some of it scatters outward in all directions. This scattering is why fog appears bright rather than dark. Light is not simply absorbed, it is redistributed. A beam from a car headlight does not travel straight forward. It spreads, illuminating the fog itself. Sunlight does not shine through fog in sharp lines. It diffuses into a gentle glow. The droplets become tiny lanterns. In physics, this kind of scattering is often described as Mie scattering. Unlike Rayleigh scattering, which makes the sky blue by scattering shorter wavelengths more strongly, Mie scattering occurs when particles are similar in size to the wavelengths of visible light. Fog droplets are just the right size for this. They scatter all wavelengths more evenly, which is why fog appears white or grey, rather than strongly coloured. Yet even in fog, the shorter wavelengths of light can scatter slightly more. This is part of why distant objects may take on a bluish-grey tint, and why fog sometimes looks cooler in tone under certain lighting. But the main effect is softness. Scattering reduces contrast. When light is scattered repeatedly, shadows lose definition. The difference between bright and dark areas becomes smaller. The world becomes evenly illuminated, like a room lit through frosted glass. This is why fog can feel like a dream. Our eyes rely on contrast to judge distance. Sharp edges and distinct shadows tell us what is near and what is far. Fog removes those cues, not by hiding everything completely, but by smoothing the visual landscape. Objects fade gradually, rather than disappearing suddenly. A tree becomes a silhouette, then a darker blur, then a suggestion, then nothing. The physics is gentle. Each droplet scatters a tiny portion of light. Millions of droplets scatter it again and again, until the original beam loses its direction. It becomes glow. It becomes atmosphere. Even sunlight changes character. In clear air, the sun is harsh and direct. In fog, sunlight becomes diffused, soft, almost tender. It wraps around objects instead of striking them sharply. This is why foggy mornings can feel so calm. The light itself is quieter. Fog also creates optical effects like halos, fog bows, and glowing columns. All of these come from the way light interacts with droplets, bending, scattering, and sometimes diffracting into faint patterns. And so, physics becomes poetry. Light meeting water in delicate collision, a beam becoming a halo, a sunrise turning into gold mist, a street lamp becoming a floating orb. Fog is not emptiness. It is filled with tiny spheres that transform light into softness, a laboratory of droplets suspended over roads and fields, a quiet reminder that even something as ordinary as water vapor can reshape how we see the world. And as we rest in this understanding, we realize that fog is not only a veil over the landscape, it is a veil over light itself, a gentle filter placed between the sun and the earth, a soft collaboration between physics and atmosphere, a luminous hush written in scattering waves. Sometimes the atmosphere arranges itself in a way that feels upside down. Normally, air becomes cooler as you rise higher above the ground. Warmth gathers near the surface during the day, and the higher sky remains cooler and lighter. But on certain calm nights, the opposite happens. Warm air settles above cooler air. This is called a temperature inversion, an invisible layer where the usual pattern of cooling with height is reversed. And when an inversion forms, fog often finds a perfect place to linger. Tonight, we float beneath that quiet ceiling. Imagine the evening after a clear day. The sun sets, and the ground begins to cool quickly. It radiates heat upward into the night sky, losing warmth steadily. The air in direct contact with the surface cools too. This near-ground air becomes colder and denser than the air above it. Normally, you might expect the cooler air to rise and mix, but cold air is heavy. It sinks and stays close to the ground. Meanwhile, the air a little higher up remains warmer because it is not being cooled directly by the surface. And so, a layered structure forms. Cool air below, warm air above, like a blanket turned upside down. This warm layer acts like a lid. It prevents the cooler air beneath from rising and mixing freely. The atmosphere becomes stable, calm, still, and stratified. This stability is exactly what fog loves. If moisture is present near the surface, from damp soil, rivers, lakes, or humid air drifting in, the cooling air below the inversion can easily reach its dew point. Condensation begins, droplets form, fog spreads outward, hugging the ground. But because the inversion blocks vertical mixing, the fog has nowhere to go. It cannot rise easily. It cannot disperse upward. Instead, it remains trapped beneath the warm ceiling, sometimes persisting long after sunrise. This is why fog can feel stubborn on certain mornings. Even when the sun is up, even when daylight brightens the world, the fog may refuse to lift. The surface warms slowly, but the inversion layer remains intact until enough heat builds to break it. Sometimes wind helps by stirring the layers. Sometimes stronger sunlight warms the ground enough to create rising currents that punch through the lid. But until then, the fog stays low. It lingers in valleys, spreads across fields, and settles into city streets. The inversion is invisible, but its effect is clear: a stable pocket of cool, saturated air held close to the Earth. This also affects air quality. Because inversions trap air near the surface, smoke, pollution, and moisture can accumulate together. In cities, this can create thicker, hazier fog. In rural areas, it can hold mist over farmland longer than expected. Still, in the quiet language of tonight, we focus not on discomfort, but on the atmosphere's structure. The inversion is like an unseen roof. Above it, the sky may be clear and bright. Below it, the world is wrapped in mist. From an airplane, you might see this clearly: a smooth sea of fog stretching across the land, with sunlight shining above it. The fog appears like a white ocean, perfectly flat, as though it has been poured into the landscape. That is the inversion's signature: a boundary between layers, a quiet dividing line between clear air and saturated air. Standing beneath it feels like being inside a soft room of weather. Light is diffused, sound is muted, the horizon is close. The air feels calm and damp, and as you breathe, you can almost imagine that invisible ceiling overhead, holding the mist in place like a gentle dome. Fog and inversions remind us that the atmosphere is not always freely mixed. Sometimes it becomes layered, organized, still. And in that stillness, fog finds its home. A veil trapped beneath warmth, a mist held close to the ground, a lingering softness that lasts longer than expected, until the sun, the wind, or time itself gently reshapes the layers once again. There is a special kind of silence that belongs to harbours at dawn. Before the day's work begins, before engines fully awaken and boats slip out too. See, the harbour rests in quiet. The water lies dark and smooth, disturbed only by small ripples against the dock. And often, in these early hours, fog arrives. It drifts in from the ocean, low and pale, wrapping the harbour in a soft maritime veil. The world becomes close and intimate. Visibility shrinks. The far end of the pier disappears into grey. Tonight, we linger in this stillness. Harbour fog is often advection fog, warm, moist marine air moving over colder water. Coastal currents cool the air from below, bringing it to saturation. Droplets condense, and the mist forms. The fog glides into the harbour quietly, carried by gentle sea breezes. Fishing boats idle in low visibility. Their hulls appear and disappear as the fog thickens. Masts become faint lines rising into the mist. Navigation lights glow softly, blurred into halos. Ropes creak against wooden posts. Buoys bob gently, their bells sounding now and then. A soft metallic note floating through the fog like a distant lullaby. Gulls call overhead, unseen, their voices echoing faintly in the damp air. Everything feels slowed. Fog changes the way the harbour sounds. The usual sharpness of noise becomes softened. Waves lapping against the dock sound quieter, more rhythmic. Voices carry strangely, sometimes fading quickly, sometimes travelling farther than expected through stable air. The fog wraps docks and hulls in quiet calm. It beads on metal rails and collects on nets. Wooden planks darken with moisture. The air smells of salt and seaweed and damp rope. Even the lighthouse, if there is one nearby, seems gentler in fog. Its beam sweeps outward, but the light does not travel far. It diffuses into the mist, creating a glowing pulse rather than a sharp guiding line. This is the harbour's morning mood, a scene painted in soft greys and muted blues. Fishermen move carefully, not rushed, their steps steady on wet boards. Engines start in the distance, low and rumbling. then fade again as boats disappear into the veil. Fog is not only an obstacle here, it is part of the coastal rhythm. Many harbours experience fog frequently, especially in seasons when ocean water remains cold while air above warms. The sea and the atmosphere are always exchanging heat and moisture, and fog is one of the most visible results of that exchange. In a foggy harbour, the boundary between water and sky becomes uncertain. The horizon vanishes completely, leaving only near water and near sound. The world feels enclosed, protected, as if the harbour has become its own small universe. And then, slowly, morning light grows stronger. The fog may thin, lifting slightly as the land warms. Or it may remain, especially if cool water continues feeding the marine layer. Sometimes the fog retreats seaward, pulled back by shifting winds. But for a time, it stays. And in that time, the harbour feels like a dream. Boats floating in silver air, ropes creaking like old lullabies, gulls calling softly above unseen waves. A maritime stillness that holds the morning gently before the day begins. Fog in the harbour reminds us that coastal life moves in quiet cycles: tide, mist, dawn, and departure. And if you listen closely, you can hear it all: the slow breathing of the sea, wrapped in fog's soft embrace. Fog does not only change the landscape, it changes the way we see it. On a clear day, your eyes rely on contrast, colour, and sharp edges to judge distance. A mountain appears blue-grey because of atmospheric scattering, and your brain understands that it must be far away. A tree trunk looks dark and detailed, and you recognise that it stands close. But in fogs, these cues soften, edges blur, colours fade, shadows dissolve, and suddenly, distance becomes uncertain. Tonight, we wander gently into the space between sight and interpretation, the way fog reshapes human perception. Our eyes and brain work together constantly, building a three-dimensional understanding of the world. We use depth cues like perspective, overlapping objects, brightness, texture, and contrast to decide how far away something is. Fog reduces many of these cues at once. When droplets scatter light, they lower contrast. Distant objects lose definition first. Their fine details disappear. Texture becomes smooth. Colours drain toward grey. This effect is called aerial perspective, and it happens naturally even in clear air over long distances. Fog simply accelerates it. A building that would normally appear crisp may fade quickly into a pale silhouette. A road may seem to end abruptly, even though it continues straight ahead. A lone tree may appear closer than it truly is, because the horizon behind it is gone. Without a visible horizon, the brain loses one of its strongest reference points. Scale becomes ambiguous. In dense fog, the world shrinks to the visible circle around you. Beyond that circle lies brightness without detail. The brain cannot easily calculate depth in this uniform field of light, so it fills in gaps with assumption. This is why fog can feel intimate. It reduces the vastness of space. It draws your attention inward to what is near and immediate. The world becomes a small stage of visible clarity, surrounded by soft uncertainty. There is also a subtle shift in brightness. Because fog scatters light in all directions, shadows weaken. The difference between light and dark areas becomes smaller. Without strong shadow contrast, objects appear flatter. Flatness makes distance harder to judge. Your brain compensates by relying more heavily on motion and parallax, how objects shift relative to one another as you move. When walking through fog, you may notice that nearby objects slide past quickly, while faint shapes in the distance remain almost still. Movement becomes your guide. Fog can also create illusions of enlargement. Bright lights, like street lamps or headlights, bloom into halos, making them appear larger than they are. This happens because scattered light spreads outward, increasing the apparent size of the source. The brain reads that glow as scale. And yet, despite these distortions, humans adapt remarkably well. Your eyes adjust to lower contrast. Your brain recalibrates expectations. You move more slowly, scanning carefully. You rely on closer cues, the sound of footsteps, the feel of ground beneath you. Fog teaches perception to become patient. It reminds the senses that not everything can be measured at once. That clarity may come in fragments rather than in sweeping views. In a way, fog reveals how much of vision is interpretation. The world does not shrink in fog. Only the visible portion does, and your brain fills the rest with memory and anticipation. Standing in mist, you realize that perception is dynamic. It is shaped by light, moisture, and atmosphere, as much as by eyes themselves. Fogs is not a failure of sight. It is a shift in seeing, a gentle recalibration of depth and distance, a softening of outlines that invites the mind to slow down and look closer. And as we drift into our next chapter, we'll reflect on how this shift in perception leads not to panic, but to patience. The quiet adaptations humans have learned when the world turns white. When the world turns white, we learn to move differently. Fog does not demand speed. It invites caution. Across roads, seas, and airfields, humans have developed quiet rituals for navigating mist, practices shaped not by fear, but by respect for limited visibility. Tonight, we reflect gently on those adaptations. On a foggy road, headlights are lowered. Drivers slow their pace. Distances between vehicles widen. The rhythm of movement changes from hurried to deliberate. Because in fog, reaction time matters more than momentum. The reduced visibility means you see less of what lies ahead. But instead of resisting this, careful drivers accept it. They focus on the lane markers immediately before them. They watch for faint red taillights, glowing softly in the distance. Driving becomes an act of attentiveness. In maritime settings, the same patience applies. Ships navigating through fog rely on radar, sonar, and sound signals. Foghorns sound at measured intervals, announcing presence in the unseen. Crews listen carefully. Speeds are reduced. Courses are adjusted slowly. The ocean does not disappear in fog. It simply becomes quieter and closer. In aviation, pilots follow instrument approaches when visibility drops. Technology provides guidance when eyes cannot. Runway visual range is monitored. Clear thresholds are respected. And if conditions are too thick, aircraft wait or divert. Not because of panic, but because of preparation. Humans have learned that fog requires humility. It teaches us to rely on tools, teamwork, and timing rather than pure sight. It encourages slower decisions. It rewards calm. Even pedestrians adapt instinctively. Walking in fog, you place your steps carefully. You listen more. You pay attention to sounds and shapes. You trust memory of familiar paths, and you remain aware of your immediate surroundings. Fog reshapes movement into mindfulness. And yet, safety in mist is not only about caution. It is also about trust in systems designed to function under uncertainty. Reflective road markers glow in headlights. Navigation buoys signal position. Airport instruments guide descent. Bridges are lit with soft illumination. The world is prepared for fog. Over time, Communities that frequently experience mist develop routines. Coastal towns expect marine layers. Mountain passes anticipate whiteouts. Drivers know to reduce speed when the air grows opaque. The adaptation becomes cultural, part of local rhythm. What might seem disorienting at first becomes familiar. And there is something deeply calming about that. Because fog does not remove our ability to move. It simply changes how we move, from fast to slow, from broad vision to focused attention, from assumption to awareness. Safety in the mist is an exercise in patience. It reminds us that clarity is not required for every step, that careful movement can carry us through uncertainty just as effectively as clear sight. And as we breathe in the quiet air, we realize something gentle. Fog does not forbid travel. It invites steadiness. It invites listening. It invites slowing down. The world may be wrapped in white, but it is still there. Roads beneath wheels, water beneath hulls, ground beneath feet. And in learning to move carefully through mist, we discover a quiet strength, a resilience shaped not by force, but by attentiveness. Because when the world turns soft and white, we do not stop living, we simply move more gently. There are moments when fog feels like pause itself. Not a pause in the way a door closes or a clock stops ticking, but a softer pause, like a held breath, like the hush that settles between two notes of music, like the silence that arrives when the world decides, for a little while, not to hurry. Fog has this gift. It can make time feel slower, not because it changes the minutes, but because it changes the way we experience them. Tonight, we rest in that timeless atmosphere. When fog forms under calm conditions, the air becomes unusually still. Winds fade to almost nothing. The atmosphere settles into layers. The temperature remains steady, and the moisture hangs suspended without being stirred away. This stability is part of why fog feels so quiet. In storms, the sky is alive with motion, rising currents, swirling winds, dramatic changes in pressure. But fog forms when the atmosphere is almost resting. Cooling happens gently. Droplets condense softly. The world becomes wrapped, not shaken. No wind, no urgency, just suspended quiet. In this stillness, sound changes. Distant noises become muted, softened by damp air and reduced contrast. The usual sharpness of the world fades away. Footsteps seem quieter. Voices sound farther. Even your own breathing becomes more noticeable, as though the fog has turned the volume of life down to a whisper. And sight changes too. Fog removes the far distance. It erases the horizon, narrowing the world into what is close. Without long views, the mind stops traveling outward. It stays near. It stays present. This is one reason fog can feel meditative. The future feels less demanding when you cannot see far ahead. The past feels less heavy when familiar landmarks disappear. All that remains is the immediate moment, the small circle of visibility around you, glowing softly in mist. Even light behaves like time in fog, diffused, slowed, softened. A street lamp does not cast a sharp pool of brightness. It blooms outward, creating a halo that fades gradually into grey. The boundary between light and darkness becomes blurred. The world looks like it is made of gradients instead of edges. In that kind of light, everything feels suspended. A tree is no longer just a tree. It is a silhouette floating in pale air. A road is no longer a path into the distance. It is a ribbon that vanishes into whiteness. A house is no longer a fixed point. It is a warm shape behind a veil. Fog turns the ordinary into something dreamlike. And dreams, too, have a timeless quality. They do not always follow clocks. They unfold at their own pace, moving gently from one scene to another. Fog does the same. It creates a world where time feels less important than atmosphere. This is not because fog is mystical, though it can feel that way. It is because fog creates uniformity. Temperature is stable, wind is calm, light is scattered evenly. The world becomes steady. In steadiness, our nervous systems relax. We stop scanning for change. We stop anticipating sudden shifts. We simply exist. In the quiet of fog, even the smallest movements become significant. A single leaf falling feels like an event. A distant bird call feels like a message. The slow drip of moisture from a branch becomes a rhythm. Everything becomes more intimate. And perhaps that is why fog feels like time. Freezing. Not because the world has stopped, but because the world has softened enough for us to notice what we usually rush past. Fog invites us to linger, to slow our breathing, to walk without destination, to watch droplets gather on surfaces and slide downward in silence. It is a pause that does not demand anything, a stillness that holds you gently, like a blanket. And in that pause, you may realize something soothing. Even the atmosphere knows how to rest. Even the sky takes moments of quiet. Even time, for a little while, can feel like it is floating, suspended in mist, unhurried, calm, and beautifully still. Eventually, fog always lifts. It may take minutes, or hours, or sometimes an entire day. It may thin in patches, rise in ribbons, or dissolve so quietly you hardly notice the moment it is gone. But the return comes, and when it does, the world reappears. Tonight, we rest in that gentle transition, the soft farewell of mist, the slow unveiling of clarity. Fog feels powerful while it is present. It reshapes everything. It changes light, sound, distance, and mood. It makes familiar places feel unfamiliar, and unfamiliar places feel like dreams. But fog is not permanent. It is a visitor. It forms when temperature and moisture balance perfectly at the dew point, when air becomes saturated and droplets remain suspended. It lingers when winds are calm and the atmosphere is stable. It thickens in valleys, clings to coasts, and drifts through forests like breath. And then, when the balance shifts, it begins to fade. The most common shift is warming. As the sun rises higher, its energy reaches the ground more directly. Soil and pavement absorb heat. Leaves and rooftops warm. The air touching them warms too. And warmer air can hold more water vapor invisibly. So, the droplets that once floated as fog begin to evaporate. Molecule by molecule, they return to vapor, rejoining the invisible moisture of the atmosphere. At first, you may notice the fog thinning. Distant shapes sharpen slightly. A tree line becomes clearer. The outline of a hill appears as a soft gradient instead of a blur. Then patches open. The fog becomes uneven, drifting in small swells. It lingers longest in shaded hollows and low dips in the land. It clings to riverbanks. It holds on beneath dense trees. But even there, it cannot resist forever. Eventually, it lifts upward, as though the earth is exhaling it back into the sky. And suddenly, the horizon returns. Distance stretches out again. The world feels larger. What is interesting is that when clarity returns, nothing has actually changed. The trees are still where they were. The road still bends the same way. The coastline still meets the sea. And yet, everything feels renewed. Fog gives us a brief separation from the ordinary. It hides the world just long enough that when it reappears, we see it again with fresh eyes. A familiar street looks softer. A meadow looks brighter. A harbour looks calmer. even sunlight feels more vivid after fog has muted it. In this way, fog is like sleep itself. Sleep does not change the world. It changes how we return to it. Fog is a soft interruption, a pause that allows the mind to reset. And when it lifts, the day feels clearer, not only visually, but emotionally. The atmosphere feels lighter. Breathing feels easier. The edges of things feel sharper. But we do not need to rush into that clarity. Tonight, we simply acknowledge the cycle. Mist arrives, mist lingers, mist dissolves, and in every stage, there is beauty. Fog reminds us that obscurity is not failure. It is not emptiness. It is not something to fear. It is simply one of the atmosphere's many moods, a gentle veil created by water and temperature, a soft lesson in impermanence. Because even when you cannot see far ahead, the world is still there, and eventually the view returns. As we close this final chapter, we remember, fog is never permanent. It is a visitor, a quiet guest of the morning and the coast and the valley. A momentary softness that passes through and leaves the world unchanged, yet somehow more tender. And as the last threads of mist lift into the brightening sky, we are left with calm clarity. The kind that feels earned. The kind that feels like waking gently from a dream. Clear skies returning, not as an ending, but as a peaceful continuation. And as our journey winds down, the mystery of fog lingers like a fading dream, dissolving gently into the quiet corners of the night. We've wandered through valleys and coastlines, through forests, harbours, and moonlit fields, watching mist gather, glow, and lift again. And now, like fog at sunrise, this moment softens too. I hope this brought you a sense of calm, and perhaps a deeper appreciation for the soft, quiet side of weather. The side that doesn't roar or flash, but whispers and settles and simply is. The atmosphere is always moving, always balancing temperature and light and water in delicate conversation. And tonight, you've listened to that conversation without needing to solve it, just noticing, just breathing. If you'd like to support these calming weather journeys, feel free to like or subscribe, but only if it feels right for you. There's never any pressure here. For now, you can rest. There's nothing left to figure out, nothing left to understand. Let your breath slow. Easy in, easy out. Imagine the last threads of fog lifting into clear, quiet sky. Feel yourself drifting, like mist rising softly into sleep. Peaceful dreams, and calm skies to you.